I blew a fly's head smooth off earlier.
What?
I said I blew a fly's head smooth. Fuck! I blew a fly's head smooth off.
Nice.
He was flying around. He landed on the mic, and he landed on the mouse pad. And I knew he was a man of culture.
Shit, smooth off.
And then I pulled out the fucking shotgun and blew his head smooth off. That's the first thing going on this current stream. First thing the stream hears.
Now you might be wondering if I'm holding back on y'all. Dreamers. That's all we have time for.
There's a time-limited mission alert available. Check navigation.
You know what I need to get as soon as I get a bike up and working again? Jesus Christ. Oh shit. Oh shit. There is a little bit of life, but it's this is mostly just decaying stuff. It's not.
The algae's building on the side of the jar because it sat in the sun for so long.
Yeah. I'll put it back. I'll spin it around to the other side though. I shook the fuck out of it and then put it back in the.
What happened?
I shook the fuck out of the 100-acre or the ponds jar just to get it. Kinda pissed. So.
so do your best to keep your head on. For phase 1, stay mobile to dodge tank shot, bait out a furlong flood as soon as the boss moves in, and blitz through the vulnerability sections as fast as possible. For phase 2, deal with BS knights as quickly as you can, first down ecospheres before they make the whole arena unsafe, and try not to let pyrotechnics visuals send you to the emergency room. Now that we're through the boss's attacks, I want to talk about ways to approach the fight, starting with weapon recommendations. My biggest tip is to bring either a Vassalok with Shattering Impact or a Latron with Cleansing Spikes, as they both make the fight much easier. I'm honestly kinda surprised that we're able to armor strip this boss, as no other super bosses let you do so, but I strongly encourage you to exploit this weakness. Because both phases can be armor stripped, this applies to both the Smoldra and Tekra versions of the tank. In addition, both phases spawn a lot of minions, which can be leveraged for on-kill conditioners, and you can also activate conditioners before entering the boss room itself. While many super bosses discourage the use of on-kill effects, they can be utilized quite easily in this boss fight, so long as you're able to reach past spawning sections before your buffs expire. Do keep in mind that almost all enemy spawns will be executed, so they can be quite tough to kill. Also, it's important to keep in mind that the first phase of the tank is only vulnerable to status effects while its weak points are down, and the second phase is completely status immune. As such, weapons built for boss damage should be primarily crit focused, though status weapons can still help with killing minions. Looking at phase 1 specifically, the tank is of the Skryim faction, meaning that it takes bonus damage from corrosive and impact.
Actually, I won't need you to.
Corrosive can be used to reduce the tank's armor during vulnerability phases, but because it's status immune to the
I won't need you to need to have you order something for me off Prime.
I think it's that useful. Personally, I find Vira to be excellent purely for the timing during vulnerability phases, though this doesn't have to be on the main damage weapon. If you want, you can use a weapon with corrosive to maximize your boss damage, along with a priming weapon for inflicting Vira. When it comes to popping weak points, precision weapons are excellent for this phase, as are exploding rods and incarnates. Incarnates are exceptionally good in general, as they can charge off of weak point hits in both phases, so they have virtually infinite ammo. If a weapon deals high headshot damage, it can often pop the weak spots in 1 or 2 shots, which makes the first phase much faster. Speed is the name of the game for phase 1, so having tools to break weak spots quickly is hugely important. For this reason, I recommend weapons like Sybaris, Sigaris, Burstone, stuff like that. Honestly though, my top recommendation goes to Latron, as it can easily one-tap weak spots while also armor stripping with Cleansing Spikes, making it a very strong dual-purpose weapon. For phase 2, the boss switches function to Tekra, meaning that it's vulnerable to gas and magnetic, and resistant to cold. The approach to phase 2 is pretty different from phase 1, so it can be a good idea to mod a weapon specifically around each phase, matching its damage types to the boss's weaknesses in its respective phase. In terms of damage, AoE and energy wave weapons are king here. Lex Prime is a fantastic option for this phase, as it can shoot through the entire tank and hit several weak spots at once. Slam weapons are also super useful, with options like Xantides, Photominer, and Sancti Magistar letting damage aim through weak zones. If you just keep slamming the boss over and over, you can clear its weak spots super fast, and slams can also kill groups of miasmites both easily and safely. Funnily enough, the AoE of Latron's incarnate form is also pretty good for this phase, making it a fantastic all-rounder. If you don't have a good amp, rapid-fire weapons like the Burstone are solid choices for taking out the ecospheres, but amp seems to be the most effective play in my experience. Because the two phases are so different, I try to use battery, and based on his symptoms of what's going on, it's a pretty strange one. So I haven't taken a look at this yet. Let's take a look together and see if we can get this figured out. All right, so based on his notes, he said that while after does turn on, he's able to detect the charger and go to the BIOS and actually see it. Let's go ahead and just kind of go through it all.
Howling bird in here.
But I'm going to plug in the charger. It's going to put the power meter here. I'm going to see what it does. It does start pulling some current immediately. You can kind of see that the spike power meter here is pulling 1.9 amps. I don't know if it is powering on. It's light here, so I'm assuming it is powering on right now. It does say that
My asshole sure does hurt.
it detects the charger in the BIOS, and it won't charge the battery, it just sits at idle. But when you unplug the charger with it on, and then plug it back in, the charger's no longer detected. And the only way to get the charger detected again is to turn the whole computer back off. Now, he bought a brand new battery from us, and a brand new charger from us, and did not resolve the issue. So there's something on the motherboard that's probably messed up, and we're going to have to kind of track that down. Now, having a symptom where it detects the charger only whenever the thing's off, and whenever you turn it on, it shows up, but when you unplug it and plug it back in with it off, it doesn't work. It's a very strange symptom. So we have 0% charge, idle, 240 watts, okay? Now, if I unplug this, they're saying basically if I unplug it and plug it back in, the charger will no longer be detected. Plug it, plug it back in, and the machine just shut off. Now the battery's at 0%, so I didn't expect it to stay on. And when I unplugged it, it stayed at 240 watt there momentarily, because there is a little bit of lag there. I'm gonna have to put like a charged battery in here in order for us to really kind of play around with this, but we can see a little bit more about the battery with the diagnostics. So this machine, to boot the diagnostics, you hold on the FN key and you press the power button. We do have it pulling some current, so it is actually pulling current from the charger. Now the machine did shut off, so I don't know if that means that it already reset its detection, but we're going to cancel out of this. We're going to go over here to our system info area and go to our help. Now all of these Dell machines have this type of screen here that will actually give us information about the battery. It will show us like what health it's in, the brand new battery from us. It will show us what voltage it has. It will also show us the current going in the battery, and then or current out of the battery if you're running off of it, and it will show you if it's idle or charging state, and then we have our detection of our AC adapter voltage. Okay, so if the charger's not detected on the laptop, then it won't charge and things like that, but it is detected and it's not charging. Is there some other issue like a battery cable or something like that? I don't know. We don't see the voltage of the battery moving at all. Now I'm going to unplug this momentarily. It'll probably shut off, but when I unplug it, see what it does.
Let me guess.
Excellent armaments, operator.
And
Please return
it just
covered
yeah,
in
this is
blood.
the point where it starts rolling.
Safe and
So
sound.
let's go ahead and open the bottom up. I'm going to plug a test battery in. That way we can kind of look at it in the same menu where we have an actual charge.
Top
so we
tier
can play around a little more,
skills.
and maybe we can kind of get a little more information. Now this laptop came in express. That means that they paid extra to move to the front of the line. And when you have weird symptoms like this, it's not always a straightforward fix. It's not like we're just, changing out a charging chip or something. Usually that's not the case. When we have something where it does detect the charger when it's off, and then whenever you plug it in with it on, something else is going on. We probably have some burnt components in the one, I bet. And the bottom is off. Alright, so let's take a quick look around. We have the main battery here. This is that OEM battery they bought from us. Has a serial number there. This is the battery. That's where it plugs in. We have 2 sticks of DDR5, 1 SSD, and then the Wi-Fi card for the fans. Looks clean. I don't see any major issues. What's going on here? I do see something that looks a little strange. What? Okay. Well, now I know why there's some charging issues. Just so we can acquaint ourselves here, we have the DC jack plugs in here. We have, this is going to be where our 20 volts is. It comes through these 4 inductors, goes into these 2 MOSFETs here. It comes out of these 2 and goes into these 2 MOSFETs. It's going to energize the main power rail here through this current sense resistor, and then this will be our main power rail voltage right here. Now this right here is what Soren would call the comeback MOSFET. This is what separates battery voltage from the main power rail voltage. And this inductor here, I don't know if you noticed here, these things are bulging and there's all this stuff going on here. That's completely burnt or shorted. This right here is completely burnt or shorted. I've never seen anything like this. I've never seen coils or inductors burned up like that. I've seen lots of them. So this right here is the charge coil for the battery. The battery's right here. So we're going to produce 12.6 volts to charge the battery right here, and it's going to go through these inductors and then go to the charge legs, or vice versa. If we're pulling current from the battery, it's going to come through here and to come back over and to go through this comeback MOSFET, which separates the 19 volts from the battery voltage. Now, if this is shorted right here, we either have current going straight across or voltage going straight across, so we could have 20 volts on the battery terminal, which is really bad. or it's just shorted closed. I guess if it's shorted like a wire, then it's sending the voltage all the way across. If it's shorted where it's open, then it's separated. There's nothing you can do. It's not going to charge. But I mean, obviously, this needs to be replaced, that needs to be replaced, and that needs to be replaced, right? That's pretty obvious. Now, I don't know if this is flux. I don't know. We have a hair here. Based on the notes, I don't think anyone's been in here, and so I don't think this is actual flux or something like that where somebody's been like soldering. I think this is probably what's oozing out from the side of this. Alright, I'm going to plug in the charger. I just want to take some measurements over here. Hopefully we don't have some crazy voltages. Alright, so I'm going to plug in the charger, and power meter says it's pulling 0.04. We do have the lid closed, so it may not try to power on its own. And we are in voltage mode. Let's just check the voltage coming out of the DC jack. Right here should be 20 volts. 20.01, and then it goes through these 4 inductors. It's going to go through a pair of MOSFETs here. It should energize this part, so we get 20 volts here, and it should energize this area, so we get 20 volts there. Okay, so this current sense resistor goes over 20 volts here, and 20 volts here. Now, the question is, do we have 20 volts here? We should not have 20 volts there. That should be 12.6 or battery voltage. So if the battery is at 10.7, we should have 10.7 here. And we have 20 volts here. So this is bad. This is very, very, very bad. Does that mean we have 20 volts here? No. So we have 20 volts on the battery terminal. I am surprised we have not blown out more. Now I think we probably have a blown power management chip also, I bet. I mean, I could imagine it's not. At this point, 20 volts on the battery terminal, no good. That's no good. So I'm going to unplug the battery. Let's get that thing out of here. I do not want to plug and test battery in here. I know that that was part of our next step. Not doing that. So our next step is going to be replacing these components here. We have to replace these 3. I'm probably going to pull the board anyway because we're going to have to see what the power management chip looks like. So the power management chip, the PMIC, that is what controls these MOSFETs, and then there's also a pair of MOSFETs that output through this that produces at 12.6, so the odds are we have something shorted there also, and we have so much heat. So I'm going to pull the motherboard out. So I think these batteries are smart enough to protect themselves from that 20 volts, but I've seen in the past when we have a short and we have 20 volts going straight to the battery, usually it will short out the charger. So I'm kind of surprised it's not shorting out the charger, but it may have something to do with the power management chip not being able to start charging, so it's not actually sending the 20 volts in, or maybe it's not, the DC chip can't communicate with the battery, or something like that, so it's not actually triggering into charging mode, because even if you have voltage at the terminal, it doesn't mean the battery's going to take it. And so maybe the battery's in like protection mode. Maybe we have some blown fuses or some blown resistors somewhere. I mean, this is when it starts getting a little bit hairy, and having an express is kind of hard to get something out the door quickly, especially if they're paying to try to get it done fast. So still going to take a long time, most likely, but we will see what we can come up with. All right, and the motherboard is out. Not too bad. So the power management chip is going to be on this side of the board. And what do you see here? I see something melted. What do you think it is? I don't know, but I'm sure it's not something that's supposed to be melted. So this plastic cover is melted. Does that mean that there's something melting underneath it, or is it just the stuff on the other side of the board? Ooh, it's more MOSFETs. And there's the power management chip. So these are the 2 MOSFETs I was discussing that produces the 12.6 volts that charge the battery, okay? So one of these is most likely shorted, or both. If both of them were shorted, actually would turn off the charger, so one of them has to be shorted. And shorted on is what I mean. So it's basically acting more or less like a wire, because a transistor or a MOSFET acts as a switch, so you put a signal on one of the legs, it allows more current to pass through, and when you take it away, it doesn't. So a lot of times whenever you're producing a 12.6, it's basically doing a PWM signal, it's tapping it really fast, and that allows it to produce a lower voltage than the full power rail. So if I measure, I'm in continuity mode here, I just want to measure to see if this thing is straight on, sure it's straight on. And, is it? Oh yeah, it is. So basically, we have 0.2 going through here. It's registering basically as a wire. It shouldn't be doing that. And then what about to the gate here? This is the gate that turns it on and off. It's not shorted there. And it's not shorted there, but it is shorted on right now. And this one is going to ground. And so if this one was shorted, then it would actually short out the whole power rail, because 19 volts is here. And this is supposed to be going on and off, on and off, on and off really fast to produce 12.6 off the middle here. And then this part goes to ground. And so if this was shorted also, then it would take the full 20 volts, take it straight to ground and short it out, but that's not happening. So we have this MOSFET's bad. The power management chip's right here. I'm assuming this thing is bad. Let's take a closer look at it. The looks fine, but you know what? I'm not going to assume it's fine. I just want to check the rest of these resistors around here. So this one should be 0. 0. This should be 10. 10. 4.7. That looks okay. Alright, so here's my plan of action. I'm going to replace this MOSFET here. Which value is it? This is the one that's actually making 12 volts right at the battery terminal. Alright, so this is a B04 and 03. I do have some of those. And let me check the other side. And what's this? This is a P21 and 03. I do have some of those also. This is a 108. So we'll choose both of those out.
Scans show Grenier are harvesting Kuba nearby. Set off the alarms to draw them out, then steal their Kuba catalysts.
So we're going to check across these.
Predictable. As expected, Grenier have shut down the environmental systems, sending modified life support capsules. Use these to sustain your environment or attach Kuba catalysts to begin harvesting. Ready for a capsule. I've delivered a life support capsule to the area. Activating it will buy you more time. Life support incoming. Life support capsule is now available. Additional life support has arrived. Life support activated. Our operative is making progress. This will help our cause. Extraction is available if you need it.
Flux and solder on this pads, or else it's not going to stick right, or you're going to be fabricating yourself. Alright, so I just squeezed out any excess underneath there because we want the chip to sit as close to the board as possible. What that does is actually acts as a heat sink. So if you have it floating on too much solder, then you're going to end up having more issues because these things do get hot when we're charging the battery. And suck up into this excess here. Alright, now I need to grab a power management chip. 9552AH. Here's a brand new one of those. These are kind of expensive, around $2 a piece, so I only replace them when we need to replace them. They do go out quite a bit because these things are the first line of defense when there is an issue, which is fine with me. I'd rather have that fail than something major on the board, right? And pretend this also. Alright, that's ready to go. Now we need to find pin 1. It's marked on the top here, and it's marked on the
Operator,
board.
were you visualizing a bloody battle?
There, but we gotta find it on
Me
here.
too.
So I'm going to try to dry it off a little bit. We don't want to overcook this chip though. So I'm just going to try to dry it off just a little bit and see if we can mess around with the polarizer. You see it? There we go. It's right there. So that's which way we're going to be doing it. Like that. So preheat the board first before you're putting this chip down. You could put the chip down and heat it up, but a lot of times you don't want cracking the chip from overheating it. So we want to make sure the solder's flowing first. That gets the board nice and hot. Then you can just kind of set it down in place so the solder got all shiny. And now we can actually put this chip down, add a little bit more flux and heat it up again. And then we can tap it. There we go. See how it kind of moved into place? Tap it like that, and we're good to go. There's a couple pins that are touching. There we go. But all the rest of them look good. I don't see any issues anywhere else. Okay. So that's ready to go. Let's go ahead and clean up after ourselves like good technicians. Okay, looks pretty good, right? Before we plug it in, we probably should take some measurements, so that's what I want to do. We're just going to go around and make sure we don't have any shorted MOSFETs. We want to make sure that we don't have any shorted components anywhere else, shorted power rails. We're going to go through and measure the rest of the inductors. Now, the fact that the machine came on usually means that the input is the issue that we're having, not the actual running of the laptop. So the 3 volt to 5 volt, 1.8. All those things should be good because it does power on. We just had charging circuit issues. So I don't think we're going to have any shorts anywhere else, but I want to make sure we don't have any MOSFET shorts. So here's that MOSFET installed. I'm just going to measure across there. No short there. No short to the gate pin. And we'll double check this one. This one was fine earlier. That's fine. And then, let's see. We'll just verify we have pin 1 correct again. So pin 1's the dot right there. And you see the dot on the board right there. Okay. And then let's just double check our MOSFETs, our protection MOSFETs, and our charging MOSFETs, and all that stuff. So no short here. And we'll just check on our main power rail to ground. No short, that'll be per second. And then this is our charge capacitor, or charge capacitor to ground. No short there. So let's see if we can clean it up just a little bit better. We might have to use isopropyl alcohol in combination with the machines. So bring up our temperature here. Okay, not perfect, but it does look better. And everything's checked out there. So now I want to plug in the charger and just make sure we don't have 20 volts going to the battery right here. So I'm going to put this in voltage mode. And I'm going to be measuring right here. We don't want 12 volts, or we don't want 20 volts coming here. We want 12.6. And I'm
plugging in the charger in 3, 2, 1. And we got 0.4, which is fine. Yeah, so that's perfect. So it didn't actually go all the way up to 20 volts. A lot of times when we shorted, it will just send the full 20 volts straight over there. It doesn't matter if it's in charging mode or not. So that's not in charging mode. Now let's double check over here, make sure we don't have 20 volts right there. Nope. So it kind of triggered up for a second, came back down, and my voltage was not fast enough to actually pick up that voltage spike. So let's go ahead and reassemble this and test. All right, the motherboard's installed. Now I'm going to start with the battery unplugged. I do have all the ingredients to have fixed this issue, but I don't know if we could resolve it all the way. So I want to start out, let's see, what do I want to do? Let's just go ahead and
Ready
turn it on.
for
It does turn
action.
on. We'll on our power meter here. Plugged it in, 0.08, 0.44, it's starting to pull some current. So we do have a CMOS reset going on because we did unplug all the power from the board and we don't have the battery plugged in. So I'm going to let it kind of go through its process. We'll see if it detects the charger properly. And then with the charger still plugged in, I want to measure the motherboard and see what voltages we're getting, making sure we do have all our voltage properly. Alright, so we are in here. It doesn't even show the battery exists because we don't have the battery plugged in, but it does show a 240 watt charger. I'm going to turn this off. And now we can plug the battery in. Let's just make sure we don't have any crazy voltages before we begin. So, main power rail, 20 volts, battery charge, 8.7. It's not 12. And then let's actually check the battery connector. Battery connector is 8.7. Alright, so I'm going to measure this exactly at the same time. And maybe we should do this under the microscope in case we do get an explosion when we plug in the battery, because there's a chance that this battery got messed up. Right, so I want to measure the voltage here while I plug it in. So now we're only at 0.3 volts. A second ago we did have 0.4, we had 8.7 volts or something like that. Figure out a good ground. Let's get another. Okay, so when I plug in this, the charger is plugged in. So when I plug in the battery, we should actually get battery voltage here, 10.3. And then we should get negotiating charge current, so keep an eye on the power meter. We should get a jump up to 0.23. And then we should start getting more voltage there. So the battery voltage, 2.5 amps now. The machine is off. And you can see the voltage of the battery is rising. 11.6 volts, 11.7, 11.67. So it is charging properly now. So we do have 2.55 amps going into the battery. And it does seem to be going up. So let's turn it on, let's boot into diagnostics and kind of look through that and see if we do have a percentage going on. So we'll turn it on, and we are at 1% charge now, and I do see 3.7 amps going into the battery right there. It does say this is a charging state. Now I would love to see if I can unplug the charger and plug it back in, but I'm going to let the battery get up to a certain percentage, like maybe a couple percent, so that way when I unplug it, it doesn't shut off. So let me let it sit here for a couple minutes and do it. Okay, we have it up to 4% charge now. So let's unplug the charger and see what it does. So what we want to see is this actually switch to idle and then say discharging. Okay, so it's discharging 2.7 amps. Remember last time we unplugged it, we just kind of shut off. Alright, now I'm about to plug it back in. 3, 2, 1. Now it should switch, the charger just got detected, it says discharging still, switches to idle. It should hang there for a minute, maybe 30 seconds, and then it will start pulling some current. See, it's doing like a negotiation. Some people think it's supposed to just start charging, and there we go. Now it's switched to charging. 3.8 amps going in the battery. So this was definitely an interesting one. I did not expect to have so many different components that were actually burned up. Now, did I have to replace all of them? I don't know for sure, but the best thing to do is actually go ahead and replace those components because I do put a year warranty on all my repairs. This customer's not going to have any issues in the future. They have an OEM charger, an OEM battery, and they have all new components there. So I'm happy to say that I'm able to get this laptop fixed really fast in express mode, and I'm going to get this shipped out today. And I'd love to know your thoughts on this one, and thanks for watching. I saved another laptop! Alright, new day and another laptop that needs to be saved, and this time we have an Alienware M15R7. Now, this one has been through the ringer. So when the customer originally got this laptop, it was randomly shutting off, so he sent it in for a warranty. They'll replace the motherboard, and then after that, he got in a car wreck, and this laptop was destroyed, and so he had a warranty claim, got it fixed up brand new again, and it worked fine for a while, and now it no longer turns on. So the laptop's out of warranty. I haven't taken a look at this yet. Let's take a look together and see if we can save this laptop. All right, I push the power button, and nothing happens. I open and close the lid. It's not triggering anything, so definitely looks like some sort of short on the board. Let's plug in the charger. Keep an eye on the power meter right now. All right, so I plugged it in, we got 0 current, okay? So it just stayed at 0, 0. Now that could mean a couple of different things. Maybe the DC jack's not plugged in, but normally when we plug in the charger, we should have some inrush current at first. So it should actually spike it to maybe 0.1 or something like that. But the resting current, when the machine's off, should be 0.02, which is 20 milliamps. And we have 0, right? Our max current drawn, you can see where it says max right there, it says 0.01. So we didn't get our initial inrush current. To me, this looks like we may have a short on the main power rail, but the laptop is protecting itself and shutting off the charger and not allowing any current to flow, which is really good. So we do have a high likelihood that we can fix this motherboard, but we're going to have to open it up and take a look at something. All right, and the bottom is off. Ooh, look at this. So this laptop does look almost new. It was rebuilt, I guess, twice. And so after that car wreck, I guess they had to replace a lot of the chassis. So very clean, doesn't look like it's very dirty. We do have 2 sticks of crucial memory. Looks like they're 32 gigs each, so probably about $700 of memory just inside this laptop right here. We have 2 NVMe slots. One of them is populated. This is it looks like an OEM battery and it's plugged in. I'm going to go ahead and unplug the battery, and we'll just make sure that's unplugged before we start messing with anything. So here's where the DC jack plugs in. You remember what we said, whenever you plug in the charger and it stays at 0, you know, a couple different reasons. Well, DC jack being unplugged would be one of them. It's plugged in, so definitely not the issue. What I want to do is I'm going to plug in the charger again. We'll keep an eye on the power meter, but we're going to measure over here. I want to see what voltage we're getting. And still getting 0.01 for a second, but let's get under the microscope and take a closer look here. All right, so the DC jack connects to the board right here. We're going to have positive voltage on this side. So if I measure right here, we should have 20 volts. And this is going to be the ground, or the negative portion of the DC jack. So we have 20 volts coming through here, coming through these 4 inductors. It's going to go into these 2 MOSFETs, which are in parallel. And since these MOSFETs are in parallel, it's going to share the current going through each one, so it allows it to actually be able to pull a lot more current. And it's going to go through another set of MOSFETs right here. Let's just see. So we have 20 volts going in, 20 volts coming out. No, we have 0 volts coming out. And so if we check the output here, we probably don't have 20 volts here. How many volts do we have? We have 0.02. All right, it's going to go through a current sense resistor, and it's going to start energizing this other area over here. So current sense resistor energizes here, goes through this inductor to go over to the battery charge circuit. These are going to be the MOSFETs that create the battery charge circuit. So we got 0 volts past that. So these protection MOSFETs are not turned on, so they're turned off to protect the motherboard from what? What is it protecting it from? Most likely some sort of short on the board. So we can look around and see if we can see anything suspicious or something like that, but I don't see anything so far. This is going to be the power management chip. This is an ISL 95522AH. This is what actually controls all these MOSFETs here. It controls these MOSFETs, which produce the battery voltage to charge the battery. This is what is protecting the motherboard. So if it senses some sort of short on the board, it will shut those MOSFETs off to protect the laptop from itself, right, from destroying itself. So I'm going to unplug the charger. I want to figure out if we have a short on the board. So I'm going to come back over here. We're going to put it in continuity mode, and we're going to start back where we started, over here where the voltage comes in. So we're not going to have a short here because we did have 20 volts, right? And it's going to go through these inductors, no short here. It's going to go through these 2 MOSFETs, and we had no short here, but we had no voltage here either. And then after that, it should come through these 2 MOSFETs, and most likely we'll probably have a short on this side, and we do. We have a short, and it's a 9.65 ohm short. So whenever you're measuring a short, we want to figure out what the ohms rating is. What you're trying to do is you're trying to figure out what is shorted, right? So if it's nearly 0, you can say capacitor. If it's like 0.3, 0.4 ohms, then you might go GPU. If it's like 2 to 4 ohms, you might go CPU. If we got 9 ohms, we could go integrated graphics on the CPU, or we can go with a different power rail altogether. So we're gonna have to figure this out. But right now we're right around 9.7 ohms. So we do have a short on the main power rail. That's what's preventing the laptop from coming on. But good news, the power management chip is doing its job. So I'm going to go ahead and get this a little bit more disassembled. We can inject voltage right now and look under the thermal camera. The odds are we're not going to be able to see anything getting hot. 9 ohms is pretty high, almost 10 ohms. And injecting anything substantial to get any current is going to be too much voltage. It will probably damage whatever we're injecting. If we try to inject 3 volts or something like that to even get anything to register on the signature on the thermal camera, then we probably will damage it. So we don't do that. We always go to 1 volt and that's it. We stop. And so that means that we're going to have to kind of probe around and see if we can find that same measurement somewhere else. So let me get this disassembled. I'm going to go ahead and just pull the whole motherboard out. I'll be right back. So I know that people want to jump straight to doing voltage injection, but if I'm measuring a short of 9.7, 9.8, you can't inject enough voltage to get enough current to get hot. I mean, one thing we could do is just kind of poke some of these other coils around here just to see if there is a short that's a little bit lower. If we have something closer to 0, we can handle that. We can inject there, but right now I'm not measuring anything there. This one's still the 9.46. This one's probably, oh, that was nothing, and that was nothing. Okay, so we don't have any shorts in this area. These might be 3 volt and 5 volt power rails. So, yeah, I'm not seeing an issue there. I'm just going to pull the board out and I'll show you how we're going to find it, okay? We don't even need voltage injection for this. So if you're at home, you don't need a thermal camera, you won't need any special tools to be able to find a short like this. Now, as I'm going, I'm unplugging things, and I'm stopping and measuring the main power rail again, just to make sure that it doesn't change, because there's a chance that we have something plugged into the board that's shorted, but it's staying there. I've already unplugged these ribbon cables, which would be these MCU boards. These MCU boards could be shorted. The RAM, I took out the SSD. We always know that it could be the Wi-Fi card, so we should take the Wi-Fi card out and see if that's shorted. Okay, the Wi-Fi card, interesting. Let's look at this. The Wi-Fi card has a strip screw in it, and the antennas are not even plugged in. Let's do somebody's thing. I think they had a note saying they took it to another repair shop first, and they think it's something wrong with the motherboard. So let's go ahead and extract that screw. The way we do that, I'm just going to use a flathead screwdriver, because this Phillips does not fit in here, but if you just use a flathead, you can just press it down in there. Get the turn usually. So if you ever have a Phillips that's stripped out, then I always just use a flathead. Get it out. This is actually a tungsten steel flathead, so you can really match down into it. Alright, and the motherboard is out. Not too bad. Alright, now I'm going to go ahead and remove the heatsink too, because we really need access to all the power rails, all the components. We need to be able to measure. So in order to find a short that's like a really high resistance like that, we need to be able to measure everywhere. So that's what we're going to do. We can also do a physical inspection. We might be able to see something blown, but I'm going to poke around.
That guy killed you?
Oh, the heatsink just came right off, so it wasn't even stuck on it, so we know that the heatsink has come off in the past. Whoa. Well, here's your problem. Oh, no! Okay, well, we know what our problem is now. Can anyone identify what the problem is? I'm going to move this a little bit over, and I'm going to zoom in a little bit. This laptop is not shipped with liquid metal. Or maybe it was at some point, but there's liquid metal on it right now, but there's no dam. So either way, if you want to take the formula that this is correct, it's not correct. There's liquid metal on the CPU, it's leaking everywhere, and there's no dam. There should be a plastic guard with a actual foam dam. Let me show you what they look like. So if you look at this board right here, this one's actually made to have liquid metal on both the CPU and GPU, and there's a foam dam around here and plastic guard, so if it ever gets out of the foam dam, it actually goes on this plastic guard. This board has nothing. And what I'm also seeing is that this actually should have element 31, which is liquid metal mixed with thermal paste, so it kind of keeps it in place. This is just straight liquid metal. Now, liquid metal is very good at thermally transferring the heat to the heatsink and will keep the laptop cooler, but it's so unsafe. And so if we look here, we do see something squirting across here, and we see a blob right there. Right there. Now, what does that control? Exactly what I thought it was, actually. This, I believe, is going to be the PWM controller for the MOSFETs that power the CPU, but which MOSFET do I think is bad? I thought it was going to be the integrated graphics, and I think I probably nailed it. I believe this is the integrated graphics MOSFET right here that has, because this CPU package right here actually has the chipset built right here, then we have the main CPU, and then the CPU will have integrated graphics. So we have power phases for the CPU itself, and then we'll have a power phase for the integrated graphics. And that usually is going to be a higher resistance. We have a blob right there that's shorting this stuff out, maybe pull this out. So let's take some measurements here. I'm going to be careful, but we're going to take some measurements. So here's what my goal is. I'm going to move this out of the way safely. Maybe I'll take
Purple things are shiny, yes, but they are deadly.
Dam on here. You know, this stuff is dangerous. So it's highly conductive. Oh, it does have some sort of thermal paste in here, but this is not element 31. You'd be able to tell. This looks like someone just added some liquid metal on top. Now, if you're a repair shop that puts this stuff on laptops, don't do it, please. It's not worth it. Laptops move around, and you're going to have liquid metal move around. It's going to leak very easily, so I do not suggest doing this. So since we do have a nice liquid ball there, I'm going to use this big syringe, and I should be able to just suck it right up. Now, if it was mixed with the element 31 thermal paste, I wouldn't be able to do this. So we should be able to just suck it right up.
You fucking die, dude.
Get it out of the way. Okay, got the liquid metal cleaned off the CPU. I'm a little
You're really
bit
gonna
less
interrupt me, you
optimistic
fucking
now
piece
that
of
this is
shit.
Terrible, because when we have liquid metal kind of moving around on the board, it starts shorting out different components. It could have just blown up the CPU for all I know. But here's what I want to do. I want to see if we can identify which power rail is shorted to the main power rail, because what basically happens is we have our main power rail comes in as 20 volts, and then that's going to power a bunch of other power rails, 5 volt, 3.3, 1.8, 1.2, 1.05. We'll have the CPU, GPU, the integrated graphics, things like that, right? VRAM. Each one of those will have its own resistance value. And when we have a value of, what did we say, it was 9.7 ohms, we want to find a rail or a power rail that is shorted to the main power rail that's bringing it down to that value. So I'm just going to take my probes. I have it in continuity mode, and so let's just kind of look around and see what we can kind of figure out. So I'm I'm going to start over here at the CPU because we do have this liquid metal ball here. And I'm not going to take that off just yet because I want to see if it does relieve itself after we find the short. If I start here at ground, right? If I put one side on ground and I measure, these are going to be the main power rail coming in, so we should have our 9.7. Now we're at 8.8, so it's a little bit lower than before. And then these are going to be energizing all of these power rails here that come into the CPU, and then we have our, there's another ball right there. And then we have our integrated graphics right here. So what I want to see is if any of these measure that same amount. So we measure here, we've got 24 ohms, 8 ohms, here's an 8 ohms right here, here's an 8 ohms right here, 8 ohms right here, 8 ohms. And this one is 160 something. So here's how I want you to figure out which one is shorted to it. I mean, that value is about the same, but if you put the negative probe now on the main power rail, and then I'm going to measure to all these. If we get a 0, then we know that that's connected. So these 4 are connected to the main power rail directly somehow, right? So that means that one of these are shorted. Basically, is acting as a wire. This could be very, very detrimental and bad. It could end up damaging the CPU itself. We hope that it didn't damage it. Now, let's go ahead and take this liquid metal ball off of here. Let's see if this relieves the short. It probably won't. Probably what happens is we had liquid metal kind of come over here, and this chip right here is what's controlling these, and probably ended up blowing out one of those. So let's see if we can pick that up. Let's see. I'm going to try sucking it up. Ooh, there we go. Sucked it up very well. So this syringe does work very well. It has to be kind of liquidy though. Alright, so those are picked up. So now we can kind of look around and see if it's changed in value. So I'm going to measure again, see if the short on the main power rail is still there. It is. And it's shorted to the CPU. So let's figure out which one of these are shorted. This one's probably fine. This one's probably fine. It's going to be one of these 4. And the way to figure that out, because the resistance is so high, we can't inject voltage or else we'll damage the CPU. Now, if you were a repair shop that said, I'm going to jump straight to voltage injection, hey, I'm not seeing anything get hot after 1 volt. What about 2 volts? What about 3 volts? What about 4 volts? You know what you're doing when you do that? You're injecting voltage straight through the CPU and you're killing the CPU. So don't do that. You need to stop, right? Whenever you measure a short on the main power rail that is, I don't know, above 2 ohms really, 3 ohms, then you're not going to be able to inject enough voltage. So we need to use the bypass method. The bypass method means that we're going to try to stop the path to ground through the CPU. So right now we have positive voltage coming through here, it's coming through one of these, it's going through these inductors here, and then it goes through the CPU back to ground. Now, when we inject voltage, we would normally stick our negative probe onto ground here, and then it would send the path through here, but we need to bypass that. So we're going to put our negative probe here, so when we inject voltage, it'll come through from the main power rail, come across one of these, and it comes straight to ground, bypassing the CPU, protecting it is the goal. You don't want to be the person who's actually blowing out the motherboard. I've seen this plenty of times where a tech will look at it, they'll inject voltage, they found that there's a MOSFET shorted on the CPU, and then they're like, it killed the CPU. You don't know. You don't know if the CPU survived or not. You injected voltage through the CPU and killed it, probably. So, I mean, if you inject 1 volt, you're fine. Don't worry about it. 1.2, you're okay. But if you start going much higher than that, you're cooking it. So we're going to use the bypass. All right, I have my voltage injection tool set up here. This is the short killer. And when you turn it on, it goes to 1.5 volts. We don't need that much because it's basically going to be a 0 ohm short because remember, if we measure across these 2 areas right here, if we measure from our main power rail to the exit of this coil, we have about 0.13. So it's basically 0. So we don't need a bunch of voltage or a bunch of current. We just need to have enough for us to have a MOSFET light up. So we can do like 0.7, 0.8, and that will be more than enough. Now, the negative on my probe here, or on my voltage injection tool, is an alligator clip, so I'm just going to clip it onto my voltmeter, and that way I can poke it here. And it doesn't matter which one we poke on, because they're all the same. And then our positive, we're going to inject on here. Alright, so I'm going to inject right now. Here we go, 3, 2, 1, keep an eye out. And I see some heat where I'm injecting, but we do see something getting hot right next to it. Now again, I don't have to inject exactly where we are injecting. So I'm going to inject now over here, we'll see if it changes. And we do see the heat right about there. Let's see. I think it's that one. Okay, we'll do it this way. Yeah, this chip right here. Okay, so we're going to go ahead and mark it with an X, so we know that's the bad one. And that way we can go ahead and get that removed and replaced. Now let's see which MOSFETs these are. I know that we ended up having to confuse the thermal camera and voltage injection. I talked about being able to find the short ahead of time without using that equipment. Well, we did technically. We figured out it was going to be one of these 4, but really the only way you can do it was using that voltage injection. So we did identify for that one. I'm going to go ahead and get it pulled off, and we'll see if the short goes away, and then we'll get it replaced and see if it's resolved. You can almost see something here. I don't know if it's a burn mark inside of it or not. Physically, it looks okay besides that little mark there, and so it's not something that you can just kind of look at and know, but that one is the only one that does have some sort of little burn area right there, or it almost looks like a burn mark. Alright, we got the bad one off of there. We're going to set it off to the side, and let's see if that short is gone. So we'll measure from the input here, this is going to be the main power rail there, and we'll measure back to ground. And the short is gone, so we have resolved the issue. So now, which chip is it? It's having a hard time seeing which one it is. I think it's the 302155. Is that what it is? Alright, so it's a 302155. I think I do have some of these NCP chips, so let me grab one of those. Alright, and I do have a pack of brand new 302155s. Oh, it's my last one. I have to order some more of these. Alright, and so before we install this, because it is new, we need to pre-tin it, which means that we need to put fresh solder on these pads in order for it to actually stick. So we have enough solder on the board and the chip, so they will go together very easily. Alright, so we don't need much. We're just going to try to get all the pins and pads having a little bit of solder on it. If we put too much, then we'll have to squeeze it out. I can see some of these ground planes underneath here, or some of these bigger pads do have a large amount, so we will end up squeezing this out. It's not the end of the world, but sometimes it's a little
Tenno, there's a time-limited mission alert available. Check navigation.
So 10-1, we need to line this up at 10-1, which is right there. Now when you're doing this, you want to heat the board up enough so you can actually see the solder start melting. So if I look closely, you can see some of the pads are starting to melt. Solder. Look at that. You can see it's starting to melt. And as we get all of it melted, we'll plop the chip down. Alright, there we go. Now I'm not concerned with it being exactly straight because it will straighten itself out. We're going to add a little bit more flux though. A little black horse flux. We'll heat it up. And I need to squeeze out just a little bit of solder underneath. You see how I'm pressing down? You see that big ball that came out there? We need to pick that up. And pick up this other little piece here. Alright, I'm not done installing it. I just wanted to get it kind of sat down in the right spot. And then now that we have it actually in place, then we can tap it and make sure that everything is soldered correctly. But when you have that big amount of solder underneath there, big solder balls, we need to squeeze it out first. So now I'm just going to tap it a little bit. And we'll press down. And that is good. So I'm going to look around the edges, make sure that everything looks good, make sure we don't have any pins that are merged together. These are big pads, that's a pad, that's a pad, and then those are all individual, and that's a big pad there, so all that looks good. Now, that it's a little bit warm, you still want to clean it up while it's warm, or else you're going to end up having an issue with the flux kind of drying or getting sticky onto the board. You'll have a hard time picking it up, so use isopropyl alcohol and the tin pad to pick that up. Alright, so before I start turning this thing on or testing it, you know the short is gone.
It's that time again, dreamers.
More liquid metal balls. Clean that one up there, hoping that chip's going to be good. And then we have, basically, it was coming out the side here, so I don't know if we're going to have any anywhere else. I still have some flux in the board before I reassemble it. But we're just going to take a quick look around the motherboard, see if we see anything. Right, so
Ta-ta, lovelies.
I don't see any other liquid metal balls on the board, so that's good news. So let me just clean up the rest of this flux that I have on the board, and then we'll do a quick reassembly and see if the motherboard is going to first. Oh yeah, we still have liquid metal on the heatsink that we will need to clear off of here because I'm not putting liquid metal back on this machine. I can put PTM 7950 on here, which is the safer bet. Oh my gosh, look how liquidy this is. We got underneath this plastic film here. We'll try to wipe it up as best I can, and then we'll see if we can catch up with the showing. Well, that just feels like a rock. Yeah, it's pretty hard. I'm going to suck that up. So that's the problem with some of this liquid metal, and actually you can start merging with the other metal, this copper, that you can replace, and the big piece actually is the same power. These actually are hard like the rock. So it's easy to pick up, but it's not that it's actually cold, it's actually kind of merging with the space. So what I'm worried about is alright, there you go. That's pretty good. Pretty cleaned up. We're just kind of doing a quick one. We don't need to sit here and spend a bunch of time trying to get this thing perfectly clean. We don't even know if the board's working yet because at this point, the CPU could be bad. We have a bad PWM controller and have another component that's shorted out because it runs liquid metal. And so we spend a bunch of time trying to get everything perfect we're getting 0.06, and we're up to 1. And terrific, nice. And we got keyboard backlight, and in here. Now, if the CPU is going to show a failure, it's going to happen pretty quick. We'll probably get a Q1 error code right here, with 2 red, 1 blue. And that could still mean we could have to have PWM control, which is actually what powers those offsets. But we're hoping that this does just resolve the issue of getting turned on. So what I'm giving a moment is to go through some reset. Here's the fans. They're running. We are at 5.3, so that's looking good. It does take a little bit of time for this to start for the first time, so we're really a bit more time. All this leading at 5.8 amps. I don't really necessarily like that. It should be moving around a little bit more. And here, let's put our chart up here, and it's flatlining. So if we have something where it's flatlining, we could have some other issue, but I'm hoping that it's still kind of going through a process. Now, really the starting process should be moving around a little bit, but I'm going to give it a little bit more time. And the fans are really starting to crank, making some noise there. And here's some grinding. I don't know if the fan housing is bent or what, but this fan's going to need to be probably redone. It's definitely getting hot, but the fans are on full blast. Can't tell. It looks like it's back off. I'm not getting a picture. Is caps lock? No, that's not responding. Okay. Alright, I hit the power button. It dropped down in current and shut off. Okay, so it actually responded to power button presses. Power them back on. Okay, it did listen to that power button press. Now we're back to 118. Doesn't look like it's posting. We're not getting an error code either, and we're not getting a response on the caps lock. This almost looks like a BIOS issue of some sort. Now, would we have a BIOS issue after having a short on the board? Most likely not. It doesn't usually happen like that. Maybe I'm just not giving it enough time. Okay, the machine is shut off on its own. What does that mean? Does that mean it overheated and shut off? That's really strange. Now I'm hitting the power button, nothing's happening. Okay, so we had it on. It was pulling a constant current, flatlining, and then the machine just shut off on its own. And now it doesn't respond to the power button presses. Okay, let me do a CMOS reset on so plug it back in. I'm going to unplug the main battery. I'm going to press the power button just to make sure anything. We'll figure out if we have another fault that happened, or is it the PWM controller that controls those MOSFETs that has failed. Alright, so battery plug back in, plug in the current, and now we're sitting at 0 again.
Each enemy is more powerful than before. Only with true mastery of the Ten of Arsenal will you succeed.
Watch out. I'm detecting void fissures nearby. Do you have a matching relic? You found a fissure. Look out for reactant. The enemies are dropping reactant. You are going to need more reactant if you want to open that relic. The Orican Neural Sentry is attempting to purge you from this place. Stand by for life support. If you have a necromech, this would be an excellent place to deploy it. Well done, Tenno. Your relic is open. If they scan you, sentient fighters won't be far behind. Has detected you. Fighters incoming. The longer you hold out, the deeper I can search. But if you need to leave, extraction is ready.
Alright, I'm just going to use this donor board right here to pull these other components off. Now this also uses MCP chips. It's totally different board, but you can see that this is set the same way with capacitor, resistor, but all three back like this. And
These manifestations must not be allowed a foothold on Lua. Life support is at risk. Destroy them. Defend yourself and use reactant to open relics. Oculists, if they scan you, sentient fighters won't be far behind. Sentient has detected you. Fighters incoming. That's it. You opened the relic. Finish your mission and we'll take a look inside. As if the Void wants us to find this.
Repaired by Dell and by repair shops. There's something in the thing. I heard before this fan part, there's something inside the thing.
Void signatures, but outside the corruptive. They are draining your life support, and fast. Eliminate them quickly. reactant is working on your relic. Find more.
They fought well. Good dance, all.
Let me see if I can just grab a test screw. Alright, so I'm going to plug in. This is a 17-inch. It should work just fine on this 15-inch. Nope, got the same symptom. So I don't know what it is. I don't know why it's coming and going, and we're able to the screen all the time. It's not. I don't think it's a BIOS issue. I mean, maybe it is, but I really don't know exactly. We just haven't got an LCD connector here. The cable seems to be not the issue, but I just took a whole second and plugged it into it. So we have to play around with this and see what we can do. I'm torn on what to do next. I did figure out what's making the fan actually have an issue. I'm going to show you. The fan is cracked. So right here, this section will slide in and start touching the bristles.
That's all I got time for anyway.
So it looks like the lack of that off this morning, or the car wreck, or many other times this thing goes apart. That will all be addressed. And this actually gets screwed together whenever you have the back on there, so it'll probably look a bit better. That's more of the screen coming on a couple times, and they're not coming not getting past the other screen. I don't know. And so I'm going to start with the BIOS just because the BIOS could resolve that getting past the other screen and resolve it maybe not pushing sometimes.
Operator, Ordis has been interfacing with the Foundry's AI presets. You could say we forged a new connection.
Oh, by the way, I was texting to
maybe like soft oil that doesn't blow away.
That's not a good form of communication. I'm not doing it.
Alright, pull the motherboard out, I'm going to hit flash the BIOS.
Alright.
You do have a new BIOS on there. It's clean, so it should work. So you can rule on that issue. We just have we have intermittent Alienware screen. We have a that goes twice, and we have to do another issue on here. So it's not only and the crap. Okay, well, let's just continue to do that. But we'll see if we're just going to put the chip away from the screen and figure out if we are resolving issues or if anything's changed at all. Okay, motherboard's in, screen connected, Starbucks connected. I did not connect the keyboard again, so we'll see that play out. I just want to see if we can get past this original screen or if we can get it through as well. Alright, plugged in, powering up again, fans are spinning it pretty high. Now, because I put a fresh BIOS on here, we're going to get the retro mode, engineering mode, and that will give the fans full blast until I get us out of that. So this is normal. I just want to see if there's a good past the flatlining process here. So we're still moving around just a little bit with 5 amps. testing. Caps lock still not working. If I hit enter, it's not changing the current. Control for the time working. Power button is delayed. It's kind of strange. You hit it, it drops the current a little bit, and then shuts off after a little while. I'll turn it back on one more time. And it's back to flatlining. I don't know. Let me grab one more test screen. I'm just not convinced that the screen is not intermittently having an issue. The fact that I'm not getting any of this, though, let me go grab a test screen. Alright, a few days later, and I still have not figured out what is causing the laptop to not fully post. Now, the screen does kind of light up, the backlight does light up, and you remember we got the Alienware screen 2 times? I haven't seen it since, and so I have it set up here on the bench, and I'm just going to try a few more things, because I haven't figured out exactly what's causing this, so I have a couple different ideas on what's going on. Now, the way I'm kind of thinking about it is, was the machine actually posting and then locking up when we got to the Alienware screen, and so now it's like not able to get to the Alienware screen, so it's still locking up before it gets there? Or do we have something that is a changing issue? Because you remember we had liquid metal leaking all over the board. Now, I went and cleaned everything, but you never know if there's still pieces left around. Here, I'm going to power it on one more time just to see what it's doing. Now, if there is liquid metal on the board somewhere that I haven't seen, I have banged the board around and got the thing to turn on or post or change or do something different. And so that might be what's going on. I'm thinking I want to send it through the ultrasonic cleaner just to make sure that we don't have any major issues. Now, I did put a new BIOS on here, so that's why the fans are blowing at full speed, because it hasn't been set yet, and we saw the flash of the screen, and then now we're flatlining. So it's not going past that. We should have an Alienware screen right here. We're not doing that. So what I want to try before we start like going the route of taking it apart and putting it through an ultrasonic cleaner, I just want to hit it around. So there's a chance that we can kind of dislodge any liquid metal if it is kind of sitting in places that it shouldn't be, especially like under the CPU or something like that. So I'm just going to bang it around on the desk. Let's plug it back in. Let's just see if it does anything different. So let's just pay attention to the current meter. I'll put the actual graph up there. All right, 2 amps. And we want to see if it does anything different. It probably won't, but we also need to kind of go around and look a little bit better maybe. I went around and looked for liquid metal, but there's a chance there's probably something under CPU. Okay, so 2.5 amps. We got the screen to flash, and that's it. I don't know if you can tell the screen's flashing, but it does flash on, and the backlight is on. If I measure the voltage over here, we do see that there is voltage on the screen connector. So we have all the voltages we need. So this is the poly fuse that powers the backlight. And let's just go ahead and take a look at that voltage. So that we do have our 19.6 volts, and then this I believe is the 3.3.
The art of combat must be practiced to truly master the canvas of war.
There are void fissures in the area.
What?
Use these to crack open a relic. You're near a fissure.
That will, at least, if I'm just missing something, it will clean that up, and hopefully we can resolve this issue. I've already put a lot of time into this. It should have been more or less a straightforward fix. You know, we did see that we had a MOSFET that blew itself back out. Now that's because we had a blown resistor, but does that mean that the CPU is bad? The integrated graphics is bad? If I never got that Alienware screen, then I'd probably start pointing to the CPU being bad, but because we did get the Alienware screen.
What?
Said no still water, so I'm gonna empty the fucking thing.
That's causing something to go on. Move around like little tower. So let me get this heatsink off. Alright, heatsink's back off again. So let's get on the microscope. Alright, so here's our CPU. We have thermal paste on it. And there's still, let's see, remnants or evidence of liquid metal. Is that? Yeah, so that's liquid metal. But I'm not concerned about it being there. I'm concerned about it being on the board. Now there could be a drop. We had that big blob that we sucked up over on this chip over here, so I guess there's still a chance that one of these chips are bad. But I'm not seeing any evidence that those chips are bad, and I don't think those actually pertain to anything over here, because I did figure out this is the PWM controller for the CPU, and the CPU seems to be working. So now we're just making sure we don't have anything else. Just moving around. Let's try and see if we have any under the CPU. A blob of liquid metal, and there's more right. So we do have liquid
Your
metal
job is to distract the enemy while a fellow Tenno operative raids the ship for much-needed supplies. Make your presence known.
Sort of weird issues. There's some more right there. Right. I'm so fast. So, Upstate Cleaner might be able to clean us up. We're still going to have to try to do our best.
They have just shut down all systems. I'm sending life support capsules your way.
On the side, and enough for it to actually... there it is.
Prepare for life support. I've delivered a life support capsule to the area. Activating it will buy you more time. Get ready for a capsule. I've delivered another life support capsule. Extraction is ready. Another job well executed.
When I do this, you're almost rinsing it off, but you're trying to take that distilled water out of there. That way it doesn't stay anywhere. And then I'm going to go blow it off with my blower. I'm trying to get behind the ship, trying to blow as hard as I can in all directions here. Don't want to leave any residue anywhere. What I like to do is I like to do it twice, just to be sure. Just to be sure. And when we're blowing it, we're also blowing all the stuff down the board in one direction. Alright, then we blow it off over time. Okay, so the board looks brand new, and we shouldn't have any more liquid metal issues or problems, I would assume. Let's just take a look around the board real quick. It looks very, very clean, very new. Now, whenever you use an ultrasonic cleaner, you'll always see this weird little residue around all these connectors. You see that kind of white stuff? That's how you can tell that it's been ultrasonic cleaned. So a lot of times the board will look brand new and clean, but you'll still have a little bit of weird discoloration around some of the components. Now, I saw this earlier. Let me take a look bit closer. This inductor looks a little suspicious. That does look burned right there. And I think this
Operator, did you hear that? It said... Cosmic background radiation is a riot!
It comes over here and actually touches over here. I've seen that before when the heat kind of touches this area, so maybe it's shorted out or something. I don't know. What's this? Looks like a soldering iron. Let's touch that. Okay. Now we're starting to see stuff we missed. Now this has been to multiple shops, remember? We got swapped out for under warranty, got hit by a car, or a car wreck. At one point I even read a note saying something about being hit by a train, so I don't really know the entire backstory here, but let's see if this thing works. Actually, the last thing I want to do before I just assume that all the alcohol's out of there, all the water's out of there, I always like to use my auger station at 300 degrees C, and I'm just going to blow behind all the BGA chips and see if I push out any extra liquid. And that'll also help the alcohol evaporate and alright, we heat dried it, we blew dry it, the alcohol dried it, we did it all. Alright, so let's put it together. This is good, I don't know where else I'm going to go with this. Alright, you can actually see that
We received intel that somebody vital to enemy operations is here. Find them and capture them.
Yep, look at that. So here's the thing.
Target located. Bring them in. The capture target has vital information that we will need to extract. We need our subject brought back alive. Success. The captive is safely in our hands. Congratulations, Tenno. Stay focused. There's a heavy unit approaching. Marines inbound. Great work. I am pleased with your performance.
Okay, now we've got up to 6 amps. Look at this. We're up to 6 amps. That's something different than a second ago, right? I don't have a battery plugged in here. Does that mean the discrete GPU is turned on? We're still flatlining. So it's on in a way where we get a screen. Caps lock still does nothing. We know that the keyboard's working. I actually put a separate MCU board, different cable, with the other one straight. And we know that's working because when the whole D goes into display test, and we know the keyboard's functioning. There is a FN output here. Let's hold on to FN and see if we can move to diagnostics, see if that does anything different. And there we go. We got that backlight just kind of flash on for a second and just kind of pulse there. Still thinking BIOS or something, firmware. The BIOS I put on there, I did not rebuild, so it was one that I already had, so I'm not 100% on it, so maybe I should try the power on the shut back off. Control escape again. I have the flash drive in the back. Let's see if we'll move to BIOS recovery. Screen flash for a second. Now we're up to 5 amps, we should get a screen. It's not reading. Oh, it is reading from the flash drive now. Or the flash drive is blinking.
Operator, were you visualizing a bloody battle?
Me too.
It has power when it blinks fast when it's actually reading from it. Caps lock not working still. It's interesting. It's like it's getting to a certain boot process and then stops. So once it's 3.83 amps, the backlight's on. When we turn this off and we can get to a higher amperage, then it will actually go to another step or another phase. And this isn't powered on. Alright, so I got it to turn on and actually started reading this. See the fast blink? So the fast blink meant that I was actually trying to read that drive. The backlight is on. So I'm going to let it sit here for a minute and see if it ever loads, but I doubt it will. Okay, so here's something different. I think this is telling me that the laptop is actually not posting all the way, it's actually locking up. So it either gets to the screen where it lights up the back of the screen but doesn't get the picture yet, or it's able to draw the whole screen, but at this point it only drew the alien head. It did not draw the actual words right here. A second ago,
Saddle up.
And it booted up and showed me the whole logo. I unplugged it, plugged it back in, and then it drew just the alien head this time. So we are having, I believe, some sort of lockup issue where it's like the startup phase, and then it gets to a certain spot and then fails. Now, I don't think it's firmware because it seems like it would be in the same spot every single time. I'm starting to lean towards like something like the PWM controller for the CPU maybe is having some sort of irregular signal. That would make sense if we had one of those MOSFETs, you know, the MOSFET that blew out, and maybe backfed into the PWM controller. And so I think I want to replace that, but I don't have it. That's the problem. I looked on every single board, so I'm going to have to order them. I've already talked to the customer, and so he's prepared to wait. So I'm going to go ahead and get those ordered, and then see how it goes. Okay, day 3. Got some more chips. Oh my gosh, you don't even understand what I've been going through with this laptop. The laptop has shorted itself out again. So the main power rail is shorted out all over again. Back to where we were before, except it's a different MOSFET this time that's shorted out. So my plan is to replace all of the MOSFETs on the CPU and the PWM controller. So I've ordered all of those chips. It's kind of a costly thing, but so let me pull this off. So our plan is to replace all the MOSFETs in the CPU, and the PWM controller. The PWM controller is what actually powers on each one of those MOSFETs and controls it, and hopefully will prevent it from blowing out, or maybe that's why it's not posting all the way. I don't know. This is kind of a last-ditch effort, and I hate giving up. And so if this doesn't work, then I'm going to go ahead and post the video. I'm going to get anybody's input from the community to see if we could try something else. It's just, there's something going on with it that I cannot figure out. So let me show you what we're looking at here. So there's our PWM controller. That's what we're going to replace there. And then we have 1, 2, 3, 4, 5 power stages to replace here, or phases. So that's the one that keeps blowing up here. And then I had, I believe, this one blow up. I did change it out now I remember. So I think I had this one blow up also. So we replaced that one twice. I replaced this one. So now we're going to replace all 5 of these and this. And this is a Hail Mary. All right, let's get to it. Now, it kind of would make sense that the PWM controller is the issue, because if we did have a failing MOSFET that backfed into the PWM controller, it will cause it to short out. Oh, this one might have been the one that was blowing. I think it is this one. I don't know why I pointed to that one. Again, you've looked at this more recently than me. It's been about a week total that I've been looking at this every day or so. I've done some videos on it, and we're going to stitch all together as one video. All right, so I'm going to pull off all 5 of these. The PWM controller too. We're going to have to pretend all the new chips because they are brand new, so I'm going to end up doing that separately on a different jig here, and that way I'm not going to put it all over the board. Now, should I replace all of these MOSFETs? I don't think so, but what I'm trying to do is just do this and get it done, right? And it does cost a little bit extra to have to replace all of those components. These aren't the cheapest, so it's going to cost about $20-something in parts, and it'll either fix it or it won't, but it'll still be cheaper for the customer if they don't have to buy a motherboard, right? That's the whole idea, is we don't want them to have to buy a $500, $600, $700 motherboard. So I'm going to get these all pre-10 and I'll be right back. Alright, we got those all ready to go. I'm going to start installing. We'll start with the PWM controller. I always like to start on the edge of the board where we're blowing air kind of this direction. Now that we have all these off of here, you can actually see this was another power phase, and so we could populate this, probably not, because it's all up. But you can see that you can actually take some of these power phases off of here and it will still function just the same. Alright, so here's our pin 1 mark there, there's our pin 1 mark there. We're going to put it in this direction right here. Hoping this PWM controller will resolve the issue. I changed out MOSFET and then it failed, but then we found a blind resistor and that fixed it, and then now the machine won't start up or get an image all the time, but I don't know if it's an image issue at all. I feel like the CPU is like starting and locking up. That's kind of what I'm guessing. That's why I'm going this route here. Alright, so that was done. So these actually have a pattern on the bottom, so we don't need to look for pin 1. We just kind of line up the pattern here, so we just put that in that orientation like that. And I'll kind of skip through this. Okay, let's clean this up and take a closer look, make sure we have all of the chips installed properly in the right direction, and that we don't have any bridged pads or anything like that. Very easy to get some bridged pads while we're working in kind of a small space like this. I know that having a screen issue kind of point to like having a screen issue, but it's not really having a screen issue, because if it comes on with a blank screen, and then sometimes it comes on with a blank screen, but then the alien head shows up, and then sometimes it comes on and actually writes the whole word Alienware on it. And if it comes on, but it never posts, it never gets past a point where we can actually do the caps lock or num lock. I've even replaced the keyboard. I've done so much stuff like off camera, I don't even know why I'm still working on this. For science. That's what we're doing it for science. Let me get the rest of this flux out of here. Alright, so I want you to right now, put a comment down, tell me the percentage. Right now I'm giving it 5%, because I'm completely fed up with this, but I'm just not thinking straight, because I'm exhausted. Alright, so what we want to do is actually post. We want to give an Alienware screen, and we want the keyboard to respond, and we want to be able to go to the BIOS. If it does all that, then it's fixed. If it just gives us a backlight, then it's not fixed. Alright, so I have a separate MCU board and a different ribbon cable here, so we don't have any frayed wires, so we don't have to think about that being an issue. So let me quickly install this and do this. Okay, motherboard is installed. Moment of truth. I'm going to reset our power meter so we can keep an eye on that. Ready? 3, 2, 1. Okay, we're pulling 2 amps. don't have keyboard backlight, but I did not plug in the keyboard backlight. We have band spin, so the keyboard should be functioning because I can hold down the D key and turn on actually goes into the display test, so I know that the keyboard's working. We just don't have keyboard backlight because I didn't plug it in. Okay, so amps, we got it to 5 amps, and then we're flatlining. Nothing's just founded. I'm plugging in a USB keyboard just for my sanity. Just turn it off and on again. So I hit the power button, and it waits, and then turns off. So it's like it's thinking about something. Turn it back on. We're not getting any caps lock on our USB keyboard. We're waiting for this backlight to come on. The backlight just came on, no picture, and we're flatlining. And then we're flatlining at 3.77 this time. Before it was 5.82. This is exactly the same symptoms before I changed it to the PWM controller. So it can't be anything to do with the PWM or the CPU MOSFETs. There has to be something else going on. We need some sort of rhyme or reason. We need to have something that's consistent. If we're having it start out and it goes to a higher current sometimes, goes to a lower current sometimes, turns on the screen sometimes, doesn't turn on the screen sometimes. I mean, like, right now we'll keep going to the 3.77 amps, so 75 watts. It's just like stops at 75 watts. Why is it stopping at 75 watts? That's a pretty round number, isn't it? I don't have a battery plugged in. This is going to be a 240 watt charger. I'm going to unplug this and do a 330 watt and see if it does something different. So 330 watts plugged in now. Power back on. Let's see if it gets above 75 watts. 75 watts, right on the dot. Still 3.8, 3.77. Okay, so we're still not getting picture. We have backlight on. So do you think it could be that other chip that I originally thought was a PWM controller? Because you know what I think that chip is? It's actually the PWM controller for the integrated graphics. And it had a big liquid metal ball on it. Let me pull the board out real quick. I just want to look at that. And I want to see if I have one of those chips on a different board, because I don't have a donor board for this, and we may be ordering another chip. And make it day 4. Let me pull the board out real quick. Alright, so the chip I'm thinking about, which I thought about earlier, but then I didn't think about it. Some of you... You've got just over 40 days.
This bird is attempting to reproduce with that man's head. But why? Well, this adorable little guy is Kakapop. And the answer to the question basically boils down to that. It fucking sucks at being a bird. What is it made for? To begin with, its wings are fucking useless. A Kakapo is huge, weighing in at 4 kilos, which is 2.5 kilos heavier than any other bird in the parrot family, which is probably why the Kakapo is literally the only parrot species on the fucking planet that can't fly. He is so rotund that he just hops along the ground. They also suck at reproducing. See, in order to attract a mate, male Kakapo will dig a hole, plant themselves firmly in it, and then start spamming vine booms at the top of their lungs 8 hours a day for 3 months at a time. The problem is their call is very low pitch, which means that while females can feel it from miles off, they can't pinpoint where it's coming from, so they end up alone. When this happens, the defeated male fucks off and attempts to mate with a rock, or, as you saw at the beginning, a journalist's head.
You've been shafted by a rare parrot.
Now, by this point, you are probably asking yourself, how the has it survived this long? And the unfortunate answer is that it really hasn't. See, the reason this feathered squeaky toy has evolved the survival instincts of a crusty sock is because it is only found in New Zealand, a place that naturally has no predators. None of what I just said is a problem when you're basically playing on peaceful. Tragically, that little Union Jack in the corner of the New Zealand flag means it was colonised by the fucking British. So suddenly, there are cats, dogs, and early on, people trying to turn the poor thing into a KFC bucket, and its only defensive mechanism is standing still. Their population dropped as low as 49 birds, and they are still critically endangered to this day. Certified British Empire moments. This bird is attempting to reproduce with that man's head.
Rat.
I have a new phone case, which is also a NES. So let's pull it apart and see what makes it tick. What this is a NES Famicom clone. It's probably based around a similar NES on a chip device as this thing here, which I've played with here before. After Nintendo's patent on the original NES ran out, everyone and their dog started producing NES implementations on a single chip that sold very little money and were more or less compatible with the original NES. These things were available for almost nothing. I think this cost me 5 Swiss francs from AliExpress, and they are ubiquitous. If I turn it on, anyone who's played with one of these before will probably get flashbacks from the music. Yeah, enough of that. If I then select English, you can see that what's on it is a million different ROMs. They're either straight copies, ROM hacks, ripped off public domain stuff, you know. Most of them run, some of them don't run very well. The compatibility of these things is not great. It's okay for what it is, which is a very cheap handheld games console with miserable controls. But if you want to play Mario 14, for example, this is where you go to get one of these. Now, I'm expecting this to be extremely similar. However, I learned of these from James' channel, and he took the lid off one. And there's a feature inside that I am very interested in. So let's just have a quick look at it. You can see in here that this is clearly a very different firmware package than on the sub. If I select English, here is the main menu, which again is quite different. These are all the usual collection of totally legal licensed ROMs, but I don't see other ROM hacks, which is interesting. There are fewer of them. I think there's only 30 odd. Yeah, there's only 3 pages. And they are displayed in this interesting colourful title screen that I am not sure that the stock NES is capable of displaying, which is rather interesting. The games are, of course, if I start one, there we go, the usual NES games. And they run okay. I'm not experienced enough with the NES to know if this is running at the right speed or sounds right. All I know is there's a mushroom there. Sometimes I can reach the end of the first level. It's either clearly emulating the NES or it's got a NOAC on board. And I suspect it's got a NOAC because that's the cheapest way to do it. If it was emulating, it would need a much more powerful microcontroller, and, you know, that costs money. So let's spudge this thing open, if I can figure out how to open it, and see how it works inside. Maybe I should turn it off first. There we go. Huh. So that was in fact glued together, but luckily it was really bad glue. So what's inside our cheap Famiclone? Well, we've got the loudspeaker, we've got the USB connector providing power and only power. There's only a red and black wire coming from there. We've got a battery with a battery protection circuit, which is nice. We have a PCB and we have the screen. We also have 324 Ultra written on the board here. which could be a model name. Let's take the PCB off and see what there is to see. It's screwed together with a whole 3 screws. There's a hole here, but there doesn't seem to be a post underneath it for a screw. And I need to take the screen out as well. Oh, that's fun. The screen has been plastic welded into place.
Tenno, there's a time-limited mission alert available. Check navigation.
Pretty rough with this thing. Okay, well, I don't want to risk breaking the screen at this point, so let's lift up the rest of the works. Start by removing the USB thing. Revealing absolutely nothing of interest. So now we should be able to lift the speaker out of the way, which I think has actually fallen into 2 pieces. Is this bit glued down? Yes, I don't think that's really very good. Here's a piece of 3M tape that's just sort of... Oh, it's double-sided sticky tape, but they haven't peeled the backing off. Wow. That's a choice. Okay, can we get the battery off? It's probably glued down. I probably also don't want to... Not sure. Easy. Okay. So now I can flip the board and see what there is. Oh, good. This is exactly what I was expecting. It's a simple PCB based around this epoxy blob. This will contain all the intelligence of the device. It'll either be a NOAC, a NES on a chip, if this is using a NOAC, or something else if this is using something else. These 2 8-pin chips, this one is bigger, and there is a label on it, but I can't quite make it out from where I am. So this is probably an SPI flash chip containing all the software. And this is something else. Power controller maybe? Here we've got all the various buttons. These things will push down on them, short out the 2 pads, and that's how the thing knows the button is pressed. And if you look over here, there's an unpopulated USB socket. If this PCB is close enough to the edge of the case, then they can just stick a USB socket here and not need the little daughter board. So if I put this down here and press, the power LED comes on, the screen backlight comes on, and the speaker makes a very nasty scratchy sound. Yeah, I think that metal thing was actually part of it. Anyone who's seen my Tony Games console video is probably going to guess what comes next. This is a flash chip. Let's dump it and see what's on it. Now, the first thing I'm going to try is this clip. I've never had good luck with these. What these are for is you clip them to the chip when they're on board, like that, and then they let you read or write the chip without desoldering it. I've never been able to make these work. The problem is that when the chip reader powers the chip to read or write it, it also ends up powering the microcontroller. And the microcontroller, of course, immediately starts talking to the chip, and that interferes with all the signals. But let's give it a try and see what happens. I might be lucky, and it would be really convenient if I were. Now, I know that this thing is a WinBond 25Q16, which MiniPro knows about, so I should be able to do this, and... Okay, well, it's reading, which is a good thing, but that's not a good thing. I think that we're getting a bad read here. It's interesting, it seemed to get the device in serial. Okay, what's in the ROM? Nothing. Yep, that hasn't worked. Fantastic. I'm going to have to remove the thing from the board. Here it is on the carrier board, so we now drop it into the chip reader the right way around. hopefully this will now work. Okay, what do we get? Right, it has correctly read the chip ID. See, here it got 0, here it got the right value. So I think we are now actually getting real data. And what do we get when we look in it? Stuff. What kind of stuff? Well, I see lots of zeros, and I see what look like jump tables or something like. So I don't think this is encrypted. Let's just run strings on it and see what comes out. Garbage, garbage, lots of garbage. There we go. Alpha, beta, gamma, delta, epsilon, zeta, eta, beta, iota. This is the Greek alphabet. It is an unencrypted ROM. Excellent. The next thing to do is to run it through CPU rec to try and recognize any machine code that happened to be in the thing. Now, since it's a NES, I expect it to find lots of 6502 code, but it might find something else. Right. That's not impressive. It's found 6 bytes of 6502 code. Right. This is garbage. So the NES boots weirdly. If this is a real NES emulation, I would expect it to start with reset vectors, which would be somewhere up here, but there is nothing. If it's a different architecture, then CPU rec doesn't know about it. We did see plain text strings, so it doesn't seem to be encrypted. I wonder if this is hooked up via an SPI bridge. The bridge knows whether the actual CPU is reading code or data. Could it be encrypting the code reads, but not the data reads? That would explain what we're seeing. That gives us, like here, this is a structured table, 014D, 014E, 014F, etc. So that's clearly not encrypted. But the actual code part, assuming this is code, is all wrong. Well, I could try and figure it out by static analysis, but it's so much easier to just hook it up to the signal analyzer and see what it's actually doing. As you can hear, it's not quite right. If I reset it, it runs fine for a bit, and then glitches out. So what I think is happening here is that my wires are too long and I'm hitting various capacitance issues. That's fine, I can always shorten stuff. And it runs for a little bit, so it's at least getting to the boot up sequence, which is good. Let me just reassemble this so I can see the screen. No, it's not working at all. I suspect something's shorting out here where all the wires are bunched together. Or then again, possibly not. The thing is, I shortened these wires in the hope that it would work a bit better. It doesn't, it works worse. If I try to reset it, there is a faint click from the speaker and nothing happens. So I immediately went to my oscilloscope to see what I did see, and not only could I see things, I saw them happening at 90 megahertz. That's really fast for an SPI chip. Not only is it really fast, it's really out of my comfort zone when it comes to electronics, and I don't think this horrible bundle of wires is going to cut it here. I think this is going to need short tracers. So I'm going to have to change my plan slightly. I'm going to solder this thing on, which is a ZIF socket attached to a SOIC 8 adapter. I've used these before, they've never really worked very well. Turns out the cheap PCBs don't really like have anything this size hanging off them. So I'm going to also have to apply lots of hot glue to hold it on, I'm not going to be able to put this thing back together, and I probably won't be able to make it so that I can see the screen, but I do want to actually get the thing running, because this is going to need rather more serious signal analysis than I thought I was going to need. I don't even know if my signal analyzer goes up to 90 megahertz. I was expecting, 8, 16. Well, here it is after some to do on camera. So we insert this thing like this. I haven't done any of the hot glue yet. I want to see if it works first. Yeah. Power. Nothing has happened yet. Now let's try the on button. Just here. I said it's here. Okay, have I got the power wrong somehow? Wire has fallen out on the power supply. There we go. Oh, that's interesting. That wanted to draw more than 150 milliamps. That suggests it's trying to turn the light on, or the signalling between the chip and the board is simply not working right. I fired up the oscilloscope, and that is showing something rather interesting, which is, if I check the power line on the flash chip, not powering up the flash chip. One thing I found which is exceptionally weird is if I do a continuity test of these two pins, this is power to the flash chip. I think I've shorted something together on the board. Either that or I've fried the power controller chip. And look here. Here are two components I appear to have dripped solder on. Let's clean those up a bit and then see if anything's changed. So I just spread the solder around a bit, and what do we get? Nothing. Okay, I think that could well have been the problem, so I shall carefully stick the flash chip back in. This thing is rather more force than I'm comfortable with. It's a ZIF socket, it's not supposed to use force. Okay, it's the right way up. 3.8 volts to the battery terminal. And hit the on-off button. Oh, red light. Ah! I mean, the speaker is not making any horrible sounds. Let's try reset. Nothing. Ah! Maybe I should reconnect this wire. Nasty scratchy sound, and it's not glitching out. Okay, the board is running, which is nice. I haven't broken it. I really ought to start ordering 2 of these things. So now I have it working. All I need to do now is figure out how to capture the SPI signals to the flash chip. So this might be harder than it looks. Let's take a look under the scope. In QSPI mode, this pin is the clock signal, which indicates the highest resolution we need to capture. That is registering 8.5 megahertz. That's not the 90 I was getting before. I wonder if this is working quite right. If I zoom in on one of these fast bits, does the signal change? Okay, yep. Now it's registering 90 megahertz. So I think that previously, like this, it's seeing those big dips as the frequency it's supposed to count. So I think that each one of those dips represents a single SPI command as it's reading bytes from the chip. And you can see that it's all structured very nearly the same. So I think it's just reading a single byte at a time, which is very characteristic of an SPI bridge. So now I need something that can capture.
Yeah, I got my Kuva
Given that my trusty signal analyzer has got 24 megahertz written on the front, I don't think this is going to cut it.
I did it because, like, Rory signed on right as you were going to bed, and I chatted with them for a little while. And I actually did pretty good. I cleared out Earth and had almost all 3 of my thingies. So once I ran out of things on Earth, I fought the guy and moved him to the next planet, and then got my last thingy, and then I went and bought a challenge ultimatum thing from the other for Kuva, because fuck it, why not? And then
so now at least
challenge.
Well,
no, I fought it twice to figure out what order, and then I challenged him.
It does this for a while. Doing various combinations of resets does help.
Right.
There we go. And
we want to try and do it without a group or with a group?
Let's do it without a group.
Attach it to some kind of test view where everything is a little bit more,
My Atmos, I got it to where I just have to do the last one where like I have to like kill like 10 enemies or some shit like that with 4 different damage type, and I don't know how to do that.
A bunch of stuff about things such as the fact that there's a huge inrush current when it's
You just gotta have 4 different elements on your.
Even if they merge into like.
There's ones that you can do, like you can put magnetic and like magnetic and radiation mods on them, and those are merged, and then you can do 2.
Did you get it knocked out already?
But it does all work with one minor device.
Yeah, I got mine finished.
Okay, ready?
Yeah, I'm ready.
This doesn't really matter. I'm not going to use
we're going to chill in the railjack until we're sure that there's nothing that's going to shoot the ship down.
Okay.
And you can actually see and hear on the remaining bits.
Where'd you get that pretty thing on the front of your ship?
Your strategy is unsound, a byproduct of emotional motivations.
You should have one too.
It shall be your undoing.
Grineer Galleon in system. High value personage aboard. Infiltrate and terminate. They have launched fires. Mission aborted.
The rupture wasn't fixed.
Did the engineer dude not go back there and do it?
No.
Tenno on deck.
Yeah, it can.
We take care of the ruptures. I know they'll do the rest.
Here you can see 8 clocks, some traffic from the device to the chip. That's the
Normally they go back there and they handle
here the chip.
Many shall ask, by what right do you judge us? Right.
Then it does some stuff I don't really understand. It looks like it's sending commands to the flash chip, but
Your strategy is unsound, a byproduct of emotional motivations and reactive thinking. It shall be your undoing.
Fighters on attack vector. Gunners, fire at will. Primary target, Grenier Galleon with support. Get on board. Locate the one calling the shots. Kill them. Hull breach ongoing. Equip your Omni and rectify this. Cruise ship reactor has detonated. Pretty.
What is it? I can't. It won't let me use my Omni.
Astral frame integrity preserved. Good job. Return to duty.
My screen is like glitching out.
Maintain pressure. Enemy cruise ship has arrived. They are powering weapons.
I'm done there, sorry.
Once I disable their engines.
Scratch one cruise ship.
I got mine
for
working.
this railjack is a memory. Breach sealed. Railjack integrity restored. Eliminated. Focus on remaining targets. Galleon has entered the fight. This changes things. Updating target manifest. Galleon captain. Board. Then kill.
I'm gonna go over and cut up the shit on the Galleon. I hate that it's doing
Yeah.
Oh shit, it's just dying quickly, that's all.
Yeah, I'm ready.
Ateno has exited the railjack.
What is this? Baby's first vendetta? This one again. That's my inevitable score, meat sack.
a great deal since last we met. You shall regret pursuing me. Supposed hunter arrives, nostrils flared, chest full of hubris. Very well. We have time for one quick lesson.
Captain terminated. Enemy routed. Reminds me of the old days. Closing mission.
Yeah.
Much better than last time we tried. Very well done.
Canceling repair order. Shields energizing. Good work.
Mission complete. Excellent work, Tenno.
Dropping Tenno out of airlock.
Something in a cartridge. This says cartridge RAM, but this is entirely up to what cartridge says. So this makes sense. But looking at it, seems to be a lot of little subroutines. So not actually standalone code. But further down, there is another block of 6002 code, which is this one. And this is aligned to a 60k boundary, and up at the top, there are indeed some bytes. These bytes do not make any sense as reset vectors, so this is the address 0103. That's actually pointing into the 6002 stack. So that would give 0103 as the interrupt vector, OOCB as the reset vector, and 0100 as the NMI vector. These make sense as addresses, but they don't point at the ROM, they point at RAMs. Something in here will have to initialize. Now the interesting thing is that while this does look like a piece of NES ROM, I would expect it to be followed by character ROM, which is not. It's immediately followed by the Super Contra ROM, which is all of this. So this is peculiar. Now I do not know how this thing actually finds various ROMs. Somewhere there must be a table telling it which ROMs are at the location in the flash and what NES mapper is using. The mapper being the memory manager chip that NES cartridges have. Emulators have to support all the various different types of memory managers or mappers, and they're identified by codes. If you download a .NES ROM image, like these ones I have here, perfectly easily, up at the top there's a header which is not part of the NES ROM at all, it's part of the .NES file, which tells it how many program ROMs there are, how many character ROMs there are, and these 2 bytes contain various flags including which mapper was in use. Of course, this thing doesn't use the .NES format, so there must be something somewhere. But my suspicion is that this stuff in blocks I've labeled MC1 and MC2 could be part of the menu system. That's only really a possibility. It's possible that the menu system is done entirely by the older way. I would think this would be unlikely, as it means that it has to be baked into the mask ROM inside the block, therefore it's very difficult to modify. It's possible. If that were the case, then all of this stuff at the top
What's that?
various menu views and so on.
Oh, I was trying to figure out like what I had weapon-wise. I have the Photor.
The more flexible way to do it is to generally just yes and no and
then I also have
then these 2 machine code blocks would be it.
instantaneous bullets. I think I might want to change that one out for the
assemble the big one.
I'm trying to figure out what's the best, like,
what we've got here is
guns. I feel like my guns did pretty good.
So this would be it.
Who's Gucci? Anything else you want to do?
I don't really care what we do. I wanna level up my new gun though.
Oh yeah, we have to go back and get it
from the foundry.
Which is exactly what we expect. This is where
back to my base.
Various NES registers live, and he goes away and does stuff. The sad thing is that I haven't found much in the way of
unread inbox messages make me ill.
I haven't found much in the way
I got a Metegro load.
This
Metegro
technology
I don't know.
right by Cube technology do have prior form in the NES world, but I don't think this device that I'm dealing with matches anything here. So I need to check this in a bit more detail. So this does suggest that we're looking at something that's not just a ripped-off NES ROM, and that this is something that's specially been written for this device. So what I'm wondering is, this capture that I got, it could be complete garbage.
This one has valence of radiation, which is
interfering with the signal enough.
Stand by while I analyze the intelligence profiles of the Grenier. Error, not a number. Did the operator enjoy this witticism?
So it's entirely possible that this thing is supposed to be executing that startup NES ROM, but is never actually getting there. I have no idea. So I think I'm just going to have to disregard the capture entirely as being of any use whatsoever. That means that the next steps for reverse engineering this are going to have to be analytical, decompiling the ROM somehow, or via experimentation. And the simplest experiment is to simply modify this startup ROM. You got that 7C00 is JSR 738. Change that to 4C be an infinite loop. So if I write this to the flash,
This does not have
and the menu
multi-shot
appears, then clearly
on it
this
at
has
all.
nothing to do with the menu. If it hangs, it's hit this instruction. So let's try it and see what happens. Programmed, plugged in, power on. It's hung. Great. This is good news. That means that piece of NES code was in fact part of the menu. This means I can now run arbitrary code on it, although that arbitrary code does think it's NES. Okay. Let's do some more playing. Progress has been made. I loaded the menu ROM into Ghidra. As you can see here, here is the fingerprints left by our mysterious Anthony. It now occurs to me, is this Anthony the same Tony who wrote the code for the other thing I reverse engineered? Anyway, this is very clearly a NES. It's doing stuff with NES registers. It looks all NES-ish. But it's more than that, because it's also writing to a bunch of non-NES registers. And this is extremely indicative of one of these. The VT369, or really it could be any of these VR technology NOACs, but I think it is the VT369. This is the most advanced NES on a chip clone. It's got lots of fun stuff like, you know, hardware multiplication and division, super fast CPU.
Well put together, operator. Now get out there and cut down the... and make the Lotus proud.
I was seeing before it went on the screen doesn't look like a NES. Once I figured this out, I then did something I should have done a long time before, which was I took the SHA1 fingerprint of the ROM I've got, and I looked for its name. And here it is. So what I'm looking at is a 36p case. That is the double quote official double quote name.
Doesn't really feel like it's gonna do much
yes,
damage.
there is some NES support. It doesn't actually work, but someone has seen one of these things before.
But I don't
now,
see.
the reason
Isn't there supposed to be like a thing up here that tells me like extra stuff about it? That it does.
BT369,
I can't see your screen.
Oh, am I not sharing?
Like initialization. And this very nicely explains
Okay.
this slow initialization by
But there was like a thing up here that
the SPI done. The machine has started up.
Because this doesn't feel like
it then goes and initializes the SPI flash, does some stuff, and only here does it
had a base
set up
status
all
of
the
50,
so
so I
that
put
it starts reading from the SPI flash. And in fact, the weird memory patterns that I'm seeing can be very simply explained by this is
the only real damage it had was radiation, so I just boosted that.
audio processor, and they're going to be
Throw away second. Do you have a secondary arcane adapter for it?
So yeah, the actual CPU traffic is going to be buried inside here somewhere, or not at all. If the system
And then you want to mod for multi-shot, because it's going to bounce to different.
Which makes my life considerably easier, but also means that there's not.
It's weird on the, but
I said earlier that the main support for this thing isn't very good. In fact, it doesn't work at all. It just produces a grey screen.
So I could just put this on instead.
We get a big warning it doesn't work, and we get a grey screen. The reason why it doesn't work is because nobody knows what the internal ROM is for this device. As the internal ROM is the thing that's actually like initializing everything and handing off this, which does make me wonder, can I find a way to dump the internal ROM? The internal ROM is of course baked into this lump of epoxy here and completely inaccessible. So I would need to find a cleverer way to do it. I've already established that I can execute code on this chip.
The enemy is at our doorstep. You must defend our equipment until reinforcements arrive. There are void fissures in the area. Use these to crack open a relic. A fissure. Defend yourself and use reactant to open relics. Use that reactant to open a relic. You are going to need more reactant if you want to open that relic. That's it. You opened the relic. Finish your mission and we'll take a look inside.
Most cunning founder, with my life I protect your sacred crowns.
Extraction is ready. Unless you can handle more of the enemy. Keep fighting. Another opportunity to extract will appear soon. Well done, Tenno. Your relic is opened. Reinforcements available. Do you choose to leave now or continue fighting? Continue to defend. You will be rewarded for your bravery. You have collected enough reactant to open your relic. Reinforcements available. Do you choose to leave now or continue fighting? Keep fighting. Another opportunity to extract will appear soon. The relic has been cracked open. Finish your mission to find out what's inside. Extraction is ready, unless you can handle more of the enemy. Very impressive, Tenno. You held them all back. Time to get out of here.
Ordis went mad for 3 milliseconds when he realized that each time he cleans something, he makes something else dirty. Ah! There I go again.
Our position has been compromised. Defend the cargo until reinforcements arrive. Void Fishers, you need them to open a relic, but are you confident you can withstand their fury? You're near a fissure. The corrupted enemies are dropping reactant. Collect it to open your void relic. Fighting. Look for more reactant. The relic has been cracked open. Finish your mission to find out what's inside. Extraction is ready, unless you can handle more of the enemy. Continue to defend. You will be rewarded for your bravery. That's it. You opened the relic. Finish your mission and we'll take a look inside. Reinforcements available. Do you choose to leave now or continue fighting? We're done here. The extraction team will take over from here. Time to evacuate.
Each enemy is more powerful than before. Only with true mastery of the Tenno arsenal will you succeed.
Void Fissures. You need them to open a relic, but are you confident you can withstand their fury? You found a fissure. Look out for reactant. Location reached. Drop me in and defend our position. I need access to a terminal. Find one and patch me in. I'm in, Tenno. This will take a moment. Stay focused. There's a heavy unit approaching.
The corrupted enemies are dropping reactant. Collect it to open the Void Relic.
The reactant is working on your relic. Find more. Still working on it. Continue to defend. Corpus walkers are heading to your location. Finished here. Move on. Terminal spotted. Upload me and prepare to defend. I'm in, Tenno. This will take a moment. Still working on it. Continue to defend. Stay focused. There's a heavy unit approaching. Hacked. Keep moving. The relic has been cracked open. Finish your mission to find out what's inside. Here is a terminal. Get me in and get ready to defend. I'm in, Tenno. This will take a moment. Still working on it. Continue to defend. against us, Tenno, but we did it. Mission complete. Stay focused. There's a heavy unit approaching.
Very good.
Welcome. Let's check what's next.
Operator, the system needs you. Will you begin another mission?
What?
The Grenier have deployed a ship killer platform to this sector. That explains the lack of civilian radio traffic. Take it down. Fighters, incoming. Keep them off the ship. Enemy fighters down 50%. Enemy fighters are routing. Cruise ship has a Tenno at the helm. Watch your fire. Grenier cruise ship has translated in sector. Boom. Cruise ship eliminated. Focus on remaining targets. sleds inbound. Prepare to repel boarders. Eyes on ship killer platform. Clearing the sector will be difficult while it is operational. Take it out of commission. Hello, disembarking. Radiator exposed. Open fire. One radiator down. Make it 2. Away crew. Wrecking time. Destroy marked components. Bingo. Crew, trash that radiator. Core is vulnerable. Marking sensitive systems. Trash the place. Ship killer platform offline. Permanently. Well done. Enemy forces pacified. Ship killer platform neutralized. Mission resolved.
Another job well executed.
Crew, a missile battery is disrupting civilian traffic in this sector. This intimidation cannot be allowed to stand. Marking objectives. Detected. Single-person attack craft. Prepare to engage. Cruise ship on scope. Ship reactor has detonated. Pretty. Cruise ship has gone bye-bye. detected. Looks like a party. Dropping Tenno out of airlock. We have been boarded. And here is the B team. Crew, fire on board. Location marked. Target, missile battery. Orders, infiltrate. Objective, expose radiators. Destroy core.
I'm down! Help me up! Or finish me off! Better get to me quick if you want to keep me breathing!
Radiator naked. Hit them with all we have got. Expose the second radiator. Hull breach. We are breaking apart. Immediate repairs. Flames extinguished. There it is. Blast that radiator. Destroy the core. Now! Key components marked. Destroy them. We have a breach. Away crew. Wrecking time. Destroy marked components. That last shot cooked off every missile rack they had. Target neutralized. Breach sealed. Railjack integrity restored. Targets eliminated. Missile battery neutralized. I will notify the Ostrons. They can turn it into a rec center. Boarding party eliminated. Ship secured. Back to work. Fire crew, stand down.
Mission complete. Excellent work, Tenno.
Crew, carbon accretion cleared from nacelles. Control surfaces recalibrated.
Operator, Ortis is sorry. Happy to report that all my good jokes are gone.
Each enemy is more powerful than before, only with... These are worthy foes. Underestimate them at your peril.
Security protocols momentarily disabled.
What you have learned here will serve you well.
Saddle up.
These foes deserve your respect. Honor them with quick deaths, and die with your victory.
Watch out. I'm detecting void fissures nearby. Do you have a matching relic? You're near a fissure. Defeat the corrupted and use their reactant to open a relic. You are going to need more reactant if you want to open that relic. That's it. You opened the relic. Finish your mission and we'll take a look inside. Extraction is ready. Unless you can handle more of the enemy. Continue to defend. You will be rewarded for your bravery. The relic has been cracked open. Finish your mission to find out what's inside. Reinforcements available. Do you choose to leave now or continue fighting? Keep fighting. Another opportunity to extract will appear soon.
Well done, Tenno. Your relic is opened.
Extraction is ready. Unless you can handle more of the enemy. Keep fighting. Another opportunity to extract will appear soon.
You have collected enough reactant to open your relic.
Ambulance is down. Hack into its systems.
My ambulance! What have they done to her? Fix this!
Reinforcements available. Do you choose to leave now or continue fighting? Continue to defend. You will be rewarded for your bravery.
You have collected enough reactant to open your relic.
Extraction is ready. Unless you can handle more of the enemy.
As you conquer the foe, so you conquer yourself.
Welcome, friends.
Welcome. That's all from me.
Ordis wonders, why is he here? Ordis supposes everyone has to be somewhere. Excellent armaments, operator. Please return covered.
There I go again, giving you too much credit. Must I always show you the way forward?
Tenno, I need you to get inside enemy data vaults and retrieve crucial intelligence data. Juggernaut nearby, it will only attack when it senses high concentrations of infested blood. Slow the fight if you want it to go away. Tenno, be on the lookout for increased security measures. The enemy would rather destroy their data than let it get into our hands. The Juggernaut has moved on. It's safe to proceed. You've triggered the alarms. Lose this data, and the mission will be a complete failure. Stay focused. There's a heavy unit approaching. Multiple targets ahead. You've triggered the alarms. Lose this data, and the mission will be a complete failure. Successfully destroyed all the data. This mission is a failure. Tenno, I need you to get inside enemy data vaults and retrieve crucial intelligence data. Tenno, be on the lookout for increased security measures. Stay focused. There's a heavy unit approaching. You've triggered the alarms. Lose this data, and the mission will be a complete failure. Successfully destroyed all the data. This mission is a failure. Tenno, you are here to infiltrate data vaults and retrieve highly sensitive enemy information. Tenno, be on the lookout for increased security measures. The enemy would rather destroy their data than let it get into our hands. Stay focused. There's a heavy unit approaching. Multiple biosignatures detected. We've got infested incoming. Stay focused. There's a heavy unit approaching. Data extracted. They won't even know it's gone. Stay focused. There's a heavy unit approaching. You've triggered the alarms. Lose this data, and the mission will be a complete failure. The enemy has successfully destroyed all the data. This mission is a failure. Your mission is to break into enemy data vaults and steal any intelligence files you find. A juggernaut nearby? It will only attack when it senses high concentrations of infested blood. Slow the fight if you want it to go away. Tenno, be on the lookout for increased security measures. The enemy would rather destroy their data than let it get into our hands. longer detecting signs of a juggernaut. Move on. You are safe. Multiple biosignatures detected. We've got infested incoming. Stay focused. There's a heavy unit approaching. You're nearing the console. Trigger the alarms now, and they will start destroying the data. You've triggered the alarms. Lose this data, and the mission will be a complete failure. Successfully destroyed all. Your mission is to break into enemy data vaults and steal any intelligence files you find. Be on the lookout for increased security measures. You're nearing the console. Trigger the alarms now, and they will start destroying the data. Stay focused. There's a heavy unit approaching. triggered the alarms. Lose this data, and the mission will be a complete failure. We allowed the enemy to destroy all their data. This mission is over.
Operator, the system needs you. Will you begin another mission? Excellent armaments, Operator. Please return
covered in blood.
Safe and sound.
These are worthy foes. Underestimate them at your peril.
Watch out. I'm detecting void fissures nearby. Do you have a matching relic? You found a fissure. Look out for reactant. The enemies are dropping reactant. Keep fighting. Look for more reactant. The relic has been cracked open. Finish your mission to find out what's inside.
What have they done to her? Fix this!
We Parent always collect our debts.
Extraction is ready, unless you can handle more of the enemy. Keep fighting. Another opportunity to extract will appear soon. That's it. You opened the relic. Finish your mission and we'll take a look inside.
This is your chance. Hack into that disabled ambulance.
Reinforcements available. Do you choose to leave now or continue fighting?
It is done, Tenno.
Operator, I've run diagnostic regressions. All systems nominal. You don't need to thank me.
The art of combat must be practiced to truly master the canvas of war.
There are void fissures in the area. Use these to crack open a relic.
They have just shut down all systems. I'm sending life support capsules your way.
A fissure. Defend yourself and use reactant to open relics. Defeat the corrupted and use their reactant to open a relic. You are going to need more reactant if you want to open that relic.
Bypass activated. Our operative is working double time.
You have collected enough reactant to open your relic.
You can't run from your past.
Life support incoming.
The murder will not go unpunished.
Life support has been replenished.
I am your reckoning.
I've delivered a life support capsule to the area. Activating it will buy you more time. Life support on the way. Life support activated. Additional life support has arrived. Prepare for life support. Our operative is making progress. This will help our cause. When you are ready, go to extraction. Life support has been replenished.
Don't forget the reactant. You need more to open that relic.
I've delivered another life support capsule. That's it. You opened the relic. Finish your mission and we'll take a look inside. Get ready for a capsule. Another life support capsule is now available. Life support incoming. Life support activated. Another life support capsule is now available. Life support has been replenished. Get ready for a capsule. Life support activated. We will all share in this bounty. Hold out as long as you can. I've delivered another life support capsule. Tenno, prepare for life support. Life support has been replenished. Additional life support has arrived. Life support activated. The relic has been cracked open. Finish your mission to find out what's inside. Life support on the way. Another life support capsule is now available. Life support has been replenished. Life support incoming. Additional life support has arrived. what our Tenno operative just found. They could not do this without you.
Very good.
Life support on the way.
Stand by while I analyze the intelligence profiles of the Grenier. Error, not a number. Did the operator enjoy this witticism? Ready for action.
This embryonic fluid injector has been recalibrated to wreak havoc on Tile Regor's cloning operation. Defend the injector for as long as possible to ensure maximum damage. There are void fissures in the area. Use these to crack open a relic. You're near a fissure.
Corrupted enemies are dropping reactant. Collect it to open your void relic.
You are going to need more reactant if you want to open that relic. You opened the relic. Finish your mission and we'll take a look inside. Reinforcements available. Do you choose to leave now or continue fighting? Keep fighting. Another opportunity to extract will appear soon. You have collected enough reactant to open your relic. Extraction is ready, unless you can handle more of the enemy. Continue to defend. You will be rewarded for your bravery. The relic has been cracked open. Finish your mission to find out what's inside. Extraction is ready. Unless you can handle more of the enemy. Keep fighting. Another opportunity to extract will appear soon. Well done, Tenno. Your relic is opened. Reinforcements available. Do you choose to leave now or continue fighting?
here will serve you well.
Operator, did you hear that? It said... Cosmic background radiation is a riot!
There is a large platoon of Grineer Marines stationed here. Leave no one standing. I'm detecting a large security force heading your way. It's the Grineer.
Get Clem! Clayton, wait!
The enemy is broken. Well done. Now get to extraction. Mission complete. Excellent work, Tenno.
Operator, were you visualizing a bloody battle?
Me too.
Let's check what's next.
All Corpus craft. Engage enemy railjack. Ice driver. Target railjack. Stop them in their tracks.
Disable all priority targets. Comet Shard. Shot down.
To Ice Driver, hit the railjack. Full charge.
Comet Shard destroyed. Good shot. Request assistance.
Ice Driver, blast that railjack with a Comet Shard.
Intruder alert. Full squad. Small arms. I'm one of those On board. Location marked.
I want torpedoes armed and dispatched now.
Hull breach. We are breaking apart. Immediate repairs. Fire alert resolved.
Come on! You guys ain't even trying! Doing the system a favor!
Crisis averted. Mission continues. Update. We are ice-free.
Ice driver loaded with comet shard. Blast them.
Kill confirmed.
Incoming comet shard destroyed. Near miss.
Let's soften them up. Torpedoes. Fire at will. Ice driver, prepare to loose payload. Target railjack.
Comet shard. Direct hit. Railjack slowed. Boarding successful. Kill that ice driver.
Torpedoes locked. Target in range. Firing.
I am in. Stay light on your feet. We are free. Engine stalled. Countermeasures have been activated. Destroy them. I cannot work like this. Hull breach. Repeat. Hull breach. Those jamming drones are a serious problem. Progress halted. Crew, patch that hull breach immediately.
Why is their signal no longer blocked? Intruder signal impeded.
Progress halted. Jamming drones. Repressurizing.
Command to ice driver, hit the railjack. Full charge. Our data grid is exposed. Yes. Burn their neurons.
Jamming drones. Yay. We are iced.
Torpedoes primed. Stand by to salvage their remains.
Hull breach. Immediate repair required.
Jamming drones. Report in. Jamming drones.
Astro frame integrity preserved. Good job. Return to duty. Progress halted. Jamming drones.
Got it done.
Are clear of ice.
Ice driver. Target railjack. Stop them in their tracks. specialist jamming agent deployed. Our data grid is safe.
Hull breached. Venting Atmo. Situation critical. Work complete. Bailing. Get to the override terminal. Incoming Comet Shard destroyed. Near miss. Omni required at Hull breach. This is not a drill. Breach sealed. Railjack integrity restored.
On the warhead. Fire full salvo. Take them.
Vice driver down.
Unassigned cruise ship located. Deploying immediately.
Priority targets neutralized. Next up, capital ship.
Ice driver loaded with Comet Shard. Blast them.
Boarding party eliminated. Ship secured. Back to work. Ateno has exited the railjack. Hull breached. Comet Shard. Direct hit. Railjack slowed. Crisis averted. Mission continues.
Torpedoes primed. Stand by to salvage their remains.
Your job is to distract the enemy while a fellow Tenno operative raids the ship for much-needed supplies. Make your presence known. Life support has been cut off. They're trying to choke you out. Hold on. I'm sending auxiliary life support.
We are clear of ice.
You failed to prevent the Tenno from boarding. Intercept them at once.
Fallen enemies will drop crucial life support. Be on the lookout. Tenno, prepare for life support. I've delivered a life support capsule to the area. Activating it will buy you more time. Get ready for a capsule. Life support activated. Life support has been replenished. Another life support capsule is now available. Life support on the way. Additional life support has arrived. Operative has just made their first discovery. Keep up the good work. When you are ready, go to extraction. Life support incoming. Life support activated. Life support has been replenished. I've delivered another life support capsule. Life support incoming. Delivered another life support capsule. time. Consider extraction. Life support activated. Life support has been replenished. Life support on the way. Another life support capsule is now available. Get ready for a capsule. The longer you fight, the more successful we will be. When you need it, extraction is ready.
Ice driver, prepare to loose payload. Target railjack.
Comet shard destroyed. Good shot.
Fighter destroyed.
Tenno disembarking. Freight linker on scope. Abandoned. Exercise caution. Still some meat on the bone.
I did bad things. If I don't pay for my actions, I don't own myself. So here I am, with you, settling my tab. I may have been born a clone, but I sure as hell ain't dying as one.
Fact is, every stable foundation is built on meat and blood. Now most people, they pretend it ain't so. It is not to their taste. Me? Hell, me? I am one hardcore carnivore. For the greater good, of course.
Yes, we eat our fallen brothers. We live short. Kids, family, not for us. If Grineer live on, it is through our brothers and our sisters, by helping them to live after we have fallen. So shelve your judgment. Luxury makes me nauseous.
Torture someone long enough, they'll confess to anything. That's my favorite thing about it. So, that helmet thing you mentioned, you ever fed anyone to it? Oh, how Zeki were artists. When they killed with finesse. Purpose. Just like me. This system's rotten. And me? I'm a scalpel. Know what I love about this ship? Everyone pulls their weight. I've been on Veil ships where we had freeloaders. One guy got so damned indolent I had to eat the bastard. Red Veil do the things most people can't. Without that, nothing survives. No cause too great, no blood too precious, is what we say. As long as it ain't mine. Torture someone long enough, they'll confess to anything. That's my favorite thing about it. So, that Hellman thing you mentioned, you ever fed anyone to it? is, every stable foundation is built on meat and blood. Now most people, they pretend it ain't so. It is not to their taste. Me? Hell, me? I am one hardcore carnivore. For the greater good, of course. Red Veil do the things most people can't. Without that, nothing survives. No cost too great, no blood too precious, is what we say. As long as it ain't mine. Oh, how Zeki were artists. When they killed with finesse, purpose. Just like me. This system's rotten. And me, I'm a scalpel. Know what I love about this ship? Everyone pulls their weight. I've been on Veil ships where we had freeloaders. One guy got so damned indolent I had to eat the bastard. Torture someone long enough, they'll confess to anything. That's my favorite thing about it.
Tenno, there's a time-limited mission alert available. Check navigation.
Operator, Ordis has been interfacing with the Foundry's AI precepts. You could say we forged a new connection. Operator, you have remembered well how the Tenno arm themselves. Project complete.
Your duty in this experiment is to dispatch as many specimens as efficiently as possible. When the time comes...
Words coming in of so many of you being your best selves. Nora is just beside herself with admiration.
Proceed immediately.
Comfy, dreamers. One of our own believes they are the equal of our foe, and baby, they are acting like it.
Go now. With each data conduit jump, the experiment's design dictates increased efficiency. I trust you will be able to complete this study, Hunter?
Enter the conduit now.
conduit is opened. Our experiment moves to a new zone. Temporarily disabled that ability. a new data conduit. Proceed immediately. Enter the conduit now. to a new zone. Hurry, Hunter! The conduit is closing fast. Hunter, the sanctuary will go on without you.
Flash and bite. The day is won not with a strike to the heart, but 100 cuts about it. Ta-ta, lovelies.
Ordis keeps a tidy ship, and is therefore reluctant to allow animals on board. In Ordis's experience, animals do not eat so much as reload.